Aggression, passive aggressiveness. I left him hanging like loose ties is loose ties. Either not, he begging to go or not. Depends on the situation. He going up like inflation. Fuck all the haters that said that he couldn't make it. My brother drowned in the lake. How could all you people mistake it? He fought hard for what he had. Murderers holding guns. You worried about all the extra to water gets in your lungs, man. Hey, how could you do this shit? How could you do this when you know I'm going through this shit? Real shit, G shit, I really do this shit. I ain't about it, but you know I'm walking through this shit. Look, 8 rounds in the 45, it go down. Look, 8 rounds in the 45, it go down. Look, 8 rounds in the 45, it go down. Yeah, 8 rounds in the 45, it go down. Yeah, 8 rounds in the 45, it go down. 8 rounds in the 45, it go down. Yeah, 8 rounds in the 45, it go down. 8 rounds in the 45, it go down, yeah.
Okay, it's been a while. We're back. Because it's been so long since I last streamed, I think it was like 2 weeks ago. I need to check that the audio is working. Okay, okay, let me just check Twitch first. Okay, let me just check Twitch first. Okay, Twitch is fine. What about YouTube? Okay, let me just check Twitch first. Okay, Twitch is fine. Okay, YouTube is fine as well. And let me just change all of the sub goal into gain amount instead. That way, we don't have to keep restarting every stream. This will be way easier. I've got a lot of things to cover as well. And it's just been so many things going on in the last 2 weeks that I think I'm just gonna condense everything into one video. Let me see if the login works. Oh, the login works now. Okay. By right, if I were to sign in here and I approve, Wait. What? Oh. Okay. Seems like it's still not working. But at least I think the dashboard is working. The thing is, I ran out of Claude Code and I'm running out of cursor as well. Like I'm literally I don't have anything left to use. I'm on like 97% cursor as well, and I'm trying to fix the issue for this. I thought I got into the user. I'm not on the waitlist anymore. I thought this was fixed. It might be like, maybe it's like a cache issue or something. Remember how do I... My monitor here is now in vertical format, so I need to split like the stream view into like 3 horizontal views instead of like 3 vertical planes. The split horizontal vertical. Oh, okay. Okay. Well. Okay. Now I have everything set up here. It's weird that this one didn't change for... Oh, that's why. Okay, the title of the stream is updated. We are going ahead to making a 0.1 version release, and right now things aren't looking good. There's just random bugs here and there. It's so weird. It's so weird, man. Okay, I'm gonna make a video on whatever has happened in the past 2 weeks on like the model releases and stuff. So well, we have like 4 model releases. Well, like technically it's 3. I think the more important thing of Sonnet is literally just there's nothing to talk about on Sonnet. And then there's Grok 4.5 as well on what's that? The benchmark dataset accidentally included in the training. Something like that. Yeah, what the it doesn't make any sense, man. Like, so like, I guess this only inflates like the benchmarks for cursor bench then. And then there was a tweet talking about this as well. Well, cursor bench. What? Why is it like not part of why is it not in like the results here? Where do I even find where's cursor bench? What? Wait. Am I tripping or what? I thought like they had a cursor bench chart or something? I'm so confused. What the fuck? .2. Yeah. I don't know why is this not like anywhere. Is I not even found here as well? Yeah, it's literally nowhere, man. It doesn't get linked from anywhere. Okay, that's Grok, Sonnet. And then we have let me pull up some of my posts as well. And also on Threads, I managed to hit 437,000 views on Threads, which is pretty insane. I have some of the links saved here as well. Where is it, man? The original post of I think it was this one. This was like the original post. Man, it's hard to like find posts when it's like not. It's hard to find the post from X, from Google. Oh wow. Okay. So this wasn't planned, but I had a very bad ulcer last week, so I couldn't like talk at all, which was why there wasn't any stream last week, in fact. And it's supposed to be I'm gonna watch AI Engineer. Well, I can just technically delete that. Wait, why is it like... Wait, what? 29:30. Well, like the days doesn't really matter anymore as well, because it's not really like accurate anymore, because like I'm literally been building review for like every single day, even over the weekends. So like this doesn't really make much sense anymore. If we were to put it here, okay, it's just yeah, let's remove those like that. So I'm changing the schedule. Initially I wanted to do a schedule sort of like Monday, Wednesday, and Friday, and then the alternate week will be Tuesday and Thursday. But like, I don't know if that's still feasible. I think like the best way right now is still really like I think we'll revert to that, because initially I wanted to change it to every week like Tuesday and Thursday, but I thought that the content wouldn't be enough. So I thought even if I couldn't publish any videos, long form or short form, at least we can publish like at least we can do like a basic, at least like a 1 hour live stream or something. So at least we can do that. So maybe we'll do it like that instead. But like 36, 37, 38, 39, like that. So I guess we'll follow this. And let me backdate. What were the... Yeah, this one. Okay, so... Advisor model, agents view. Yeah. I'm not sure about the short form content, man. I think the short form content will only upload once per week, because it's quite hard to like make the short form content when we don't have really any idea what to make. But I think I can let's look at the YouTube and shorts. Let me see what I have here. Ah, okay. Well, like the published ones I can already remove, because I don't keep them at all. Okay. Well, I think the problem is still now, I don't think we will have like content to push out until we have like literally like the base up. And I'm hoping to get the base of this to be up by the end of the week, so that we can actually start using it and actually get real people to use it and get feedback from this. So that this will be like very important. And I don't know. should we even cover on all these content? Because this is a bit like outdated already. It's like over 2 weeks of content. We might not even like do a video on all this. You know what? Fuck it, man. Fuck it. I still need this to be fixed first. I guess we can literally do like a daily live stream if you don't upload videos like every single day. Because like the bottleneck is really like uploading the videos. That's like the hard part. I think long form is still not so bad, but like short form is so hard, man. But like the long form don't get any views at all. So what we're gonna do today is, meanwhile, because I don't have I don't have any usage left of while I'm using cursor to debug why the waitlist is still broken. Let me see. Well, my usage resets at 9 PM. So like I don't know, like because of the schedule of everything, if you look at the previous week so far until here, it's like it's been so hard because like the streams are on Tuesday and on Tuesday I don't because the streams are on Tuesday and I don't have my limit resets on Tuesday, so I have to use it up by Tuesday, which means every Tuesday I don't have anything to show. Like I don't have anything to build because everything is, I don't have any limits as well. So I was thinking to get open code Go as well. This seems to be like a pretty good plan that we can use for like cheaper tasks. I feel like Ryu itself is really not easy to build. All these small models definitely cannot build it, because when I was building the early phases of Ryu, it was pretty hard. In a sense, when I was using Sonnet, I was going around in circles and the code that it was producing by Sonnet was pretty bad. And then when I switched to Opus, like the difference was night and day. And that really accelerated the development just by switching to Opus. So instead, because I don't have anything to show, while this is like troubleshooting, and hopefully this will be fixed and we can actually see like something there. And right now, the website is already up. I don't know why Zen has not fixed this yet. It's so annoying. So the website is already up. You can find it in, well, it's on the screen. And I'll paste it in the chat as well. This will be out soon. We have the open source GitHub already, which is a mirror of whatever that's from internal. So this is a mirror from our internal source code, and we have a 0.03 release, which is what I'm running here. I think I'll publish a 0.04 to fix this. And then once that's done, hopefully the first somewhat officially released version will be out. And we already have 34 stars here, which is pretty good. So I was thinking to get open code Go as well. And that's about it. So while it's trying to troubleshoot that, and the website is still very rough at the moment. I think this needs to be redesigned as well. It's pretty, I don't know why is it so bad. Like the literal source code is there, but I can't copy the design. I just don't understand why it cannot do that. But like we have the download button here for like the different platforms, the extensions. Yeah. And there's a web app as well. So if you go to the web app, I think we need to set the, hey, Aura Intelligence. I'm building Ryu, man. It's well, it's pretty rough. You can go to the website in the description, well, in the chat here. It's hard to like pinpoint what is Ryu still, but like I think at this point, Ryu is like the open platform for all of the agents to come together, and then humans to collaborate with agents. And then because it's multiplayer, many people can work on the same things at once. I think that's what we are going for here. And then it comes with tools, security, memory, the cost saving, and the model routing, all built in with local AI support as well. It's like a whole suite of, well, it's literally like a whole suite of tools bound into like a whole platform here, which is what's really amazing about this. But like, it's hard to explain when I can't demo anything. So like, that's the problem with like Reel so far. Like the past 2 weeks I've been building, because I have nothing to show. I just need to let it build so that we can have a first version to get it done so that we can actually show and then make videos about it. But like, I'm still so far away from like the first version. At least like we have like some sort of like a version here, but it's just that there's bugs everywhere and I don't have anything to show as well. So I'm hoping by the end of the day, we have something to show and this thing is fixed. I think once this wall is fixed, I think it should be ready. Because I've tested like some parts of the app. I think it's fine. And then we just need to iron out some bugs. I think by the end of the week, we should be able to do that. And the problem is I literally run out of the usage on the 20x plan already. So that's the problem here. Like, I'm not slow because I want to, but like I have no choice. But like I'm using Cursor with Composer here as well to get it to fix like more simpler bugs. I'm not gonna lie, Composer is pretty good as well. But like, I feel like some of the harder bugs of like authentication and stuff is still not very good. And Opus is still really like the model to do that. And I've tried Codex as well. Codex, I run 2 prompts and then that's it. Like the whole window, 5-hour window is gone. Just from 2 prompts. So keep a lookout. This, let me paste the link to this in the chat as well. This is an open source platform, by the way. It's fully open source. And this will be out soon. So you can visit a website as well. And it's still pretty rough, I would say. Like, I think this is fine. But like, all the visualizations here don't really make sense yet. I still need to... I really don't know, man. Like, I feel like agents still really don't get like the big picture of everything. Like, what the fuck does this even mean? Like, Dread, you know, the moment... It doesn't mean anything. Like, from even me reading it, and I've told it to change this already, and it still doesn't really get like, what am I asking for? And then I think this is fine. We have like 900,000 skills out of the box, 400 models with just 1 subscription, and you can have access to 2.8 million local models through Hugging Face, and 30 agents supported in the platform. And there's a web app as well. Let me just set the link first. So if you want the app version, this is not working either. But like it's well, it's like literally like the same thing here. Put on the web instead. And it will just connect to your local node. So without anything working, I have nothing to show, man. I've just been troubleshooting like every single thing, getting everything to work for so long. But hopefully we'll get it somewhere by today, man. It's just the problem is I don't have like any limits because of the stream schedule as well. I mentioned earlier because I stream on Tuesdays, and like earlier I was trying to, I want to stream on like every Tuesday and Thursday, but then I decided that I'll change it to Monday, Wednesday, and Friday on like alternate weeks instead. And then this might change as well from like from here onwards. I think this will be back to Tuesday and Thursday. In fact, or we could do like because I have things going on like Wednesdays of the week. So like I might have to like block out Wednesdays here. So that at least like we have an additional day here like that. And then we can at least maybe do it like this. Like well like that. like that. 44, 45, 46. Okay. So we'll do like the start of the week, the natural day, and then we'll do one at the end of the week as well, like that. I think that will work. Instead of actually this will be like here already. Holy shit, like this doesn't really make any sense. What the fuck am I doing? I guess we can do this. Actually, by then, we should have like some sort of thing up already. And we will have more things to show. So like the whole problem with like the last 2 weeks. And more than 2 weeks in fact. Because I just didn't have anything to show. And by the time it's Tuesday, I ran out of limits and I have nothing to build on stream as well. Because I have nothing that I can continue. And last week I was just down with like a very bad ulcer, so I can't even do any talking. So that's that. But from now, I think this will be like the schedule for like the next 4 weeks. And then from here, I think things are a bit uncertain here. But like, I'll leave it like this for now. So what we're gonna do today is to watch AI Engineer. And there's just so many videos. I'm hoping that we can at least like clear... They're just uploading like videos every single day, man. So I'm just hoping that we can at least clear like somewhat. Because like, I haven't watched like the videos because there's just so many. And like, I don't think like most of it, I need to watch like all of it. But like, from the recent one, maybe like 2 months ago, 6 months, 3 months. I guess maybe it's from here onwards or so. But like there was just so many, man. Holy shit. And I'm gonna watch it on stream. So we're gonna watch one video by one video. And we're gonna see if there's anything useful for real as well. While it's trying to troubleshoot, or cursor is trying to troubleshoot this. So I'm just gonna start on the first 6 videos. Let's watch it together on stream. And we'll see how this goes. It's definitely interesting.
Please welcome to the stage the research scholar at Leibniz Labs, Eric Meyer.
Wait, should I just watch in the earpiece instead? Let me just make sure there's audio as well on This might take a few days to watch finish, man.
Let me first get this out of the way. This is not a product pitch or announcement or anything. It's a 20-minute tutorial of how you can use elementary type systems and compiler
Okay, let me just
AI
confirm
safe.
that there's
And
audio
that's
on
my
like
small message
all the
today. Hopefully
platforms here.
that inspires some of you that next year you will have a booth downstairs where you have kind of like,
Confirm
provably
that there's
safe.
audio
And
on
that's
like
all my small
all the
message today. Or who knows,
platforms
maybe
here.
some of you have already solved it. Let me know, and then we can grab a coffee instead of doing this talk. With that out of the way.
Okay, there's no audio on Twitch. Let me fix that. Okay, there's no audio on Twitch. Let me fix that. Well,
No permissions, and then you say yes, 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 but I like to live dangerously. But I'm convinced that if there's anything between the model's goal and where the model currently is, it will do everything that it can to reach that goal. But I'm convinced that if there's anything between the model's goal and where the model
okay.
currently is, it will do
I think
everything
it's
that it can to reach that goal.
fixed.
Okay.
If I think it's fixed. Let me just check the YouTube one again. If I think it's fixed.
We don't have any protection in place.
Let me
And I
just
think
check
that's
the
very sad
YouTube one
and very
again.
scary. So let me tell you the story.
Okay,
How
this
we got there,
is
and I will have some characters
YouTube.
like Claude, and we will see Dario, Daniela, Sam, Bernie,
Just check
but
the
and
YouTube one
very
again.
scary. The main character is our
Okay, this is
Claude here. I
YouTube.
think you can all remember November 30, 2022. This was kind of like a very special day in history.
Okay, okay. I think the order is there for all the
And it was,
platforms,
you know,
so we're good to go.
I think for me at least that
Please welcome to
Man, there's so many companies, man. I thought like, holy shit.
Please welcome to the stage the research scholar at Leibniz Labs, Eric Meyer.
What's this one about?
well, can you go back one slide? Sorry. All right. Good afternoon, everybody. Thanks for being here after a long day of talks, exhibits, side effects. Oh, sorry, that was the side events. I hope that you have as much fun watching this talk as I had creating it. Let me first get this out of the way. This is not a product pitch or announcement or anything. It's a 20-minute
Maybe let's let me change the stream title as well. Watching AI engineer.
tutorial
Okay.
of how you can use elementary type systems and compiler knowledge to make AI provably safe. And I'm sharing all my secrets with you today, hopefully to kind of inspire some of you that next year you will have a booth downstairs where you have kind of like, created a provably safe agentic harness. Or who knows, maybe some of you have already solved it. Let me know.
Well, in fact, we're like building the same thing as well. I think watching this actually helps me analyze like what's going on as well, and then I can actually show it as well while we're watching on stream as well. And well, I hope that once this is fixed, we have things to show. But it's, I don't know, like cursor is super slow, man. They have the fast mode, but it drains out your usage even more. So it sucks. I might just literally go with OpenCode Go and try it out, because from what they claim here is that you have an insane amount of usage on GLM and Minimax and Mimo 2.5 Pro, which are good models there. And like the cheap version of the non-pro version is actually 30,000 per 5 hours, which is pretty insane. And for $5 a month, well, like $10 after that, you get $60 of usage based on the docs here that they mention. Well, it's not a direct one. I think they have. Yeah, well, it's literally here. $60 of usage and $30 if you max it out. Yeah. So if you max out the... Well, I guess once you hit like the monthly limit, I guess you can't continue like the other limits anymore. But I need to try it out because I've heard good things about it. We have to try and we'll see how it goes. And it's not that bad as well for $5 a month.
With that out of the way, let's get going. While I was preparing these slides and the site, and then when my attention waned for a second because I was trying to convince the model to draw some pictures that it didn't want to do, and you will see some of these pictures later, you can guess which ones were rejected. Suddenly, wham, Claude Code deleted one of my files. And I'm sure this has happened to you before, or maybe not.
That is actually the exact problem that we're trying to solve here. In fact, if we look at the gateway here, this is where we are doing everything, where we have like a firewall sitting in front of the agents and actually doing like the budget redaction of sensitive data like API keys and personal data, and doing evals and stuff like that, and doing model routing as well. All of it is like built in. So it works with any agent. That's like the best part about what we're doing here. And more people are realizing that this layer is actually very important to build. And the fact that we started building way ahead puts us ahead as well. But like, we don't have the same amount of budget and funding as the big teams do. But definitely we will get somewhere as we try to navigate this and make this a useful tool. But definitely making the first version to getting people to actually use it will definitely get us more ahead than just building in like stealth mode and not with like no users. Definitely having real users is more important here.
Everything with no permissions, and then you say yes, 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 but I like to live dangerously. But I'm convinced that if there's anything between the model's goal and where the model currently is, it will do everything that it can to reach that goal, including killing us, or deleting your files, or deleting your database. So I think that these models are intrinsically very, very dangerous, and we have to tame them. So that's what my talk is about. So let's get start this story. And it's, I think, a very, very sad story, but also a scary
What
story.
is this company
of how we
about?
as an industry got to this point where we are about to let
Oh, it's a
people, the general
person.
public, give control of their
It's not a
computers, their
company.
finances, their whole personal lives over to AI agents. And we don't have any protection in place. I think that's very sad and very scary. So let me tell you the story, how we got there. And I will have some characters like Claude, and we will see Dario, Daniela, Sam, Bernie. But the main character is our friendly pit, Claude here. I think you can all remember November 30, 2022. This was kind of like a very special day in history, because this was the first time that you could speak to your computer. You could say, summarize my emails, and it would,
I'm sorry, by the way. I'm watching at ×2 speed. So it's well, because we're watching at ×2 speed, some of you might not be used to it, but like we have hundreds of video to watch through. But like I'll try to watch like the important ones, and we'll skip whatever that's not important. And just to try to figure out like what's going on here to get some intelligence as well.
Realize that by introducing this innocent-looking function here, LLM, that takes a question and returns an answer, that would open Pandora's box, and that would change our history forever. But before we continue the story, this conference is called AI Engineer. All right, so we are engineers, and maybe we're the last generation of engineers that still understand what this is, what code is. Or maybe most of you have already forgotten what code is, because all your code is written by agents. But if we look at this signature here, it says the LLM takes a question, returns an answer. The question and answers are not strings. They're very complicated JSON structures, and they get more complicated every day, every time a new release of APIs comes out. But for this talk, we can just assume that question and answer are just opaque types. We don't care about how they look like. We do care about what they represent. Now, anyway, the euphoria of these LLMs as being great tools didn't last very long. And just when we thought that we have eradicated the smallpox of computer science, SQL injection, it came back with a vengeance. Because the bad guys discovered that you can trick LLMs using prompt injection, and LLMs have make no distinction between code and text, and so they're very, very easy to trick. And this, I think, is a bigger problem than SQL injection ever was. But it was not prompt injection only that made LLMs kind of have a bad rap. LLMs are trained on the whole internet, and there's a lot of good stuff on the internet, but also a lot of bad stuff, like how do you create a bomb, how do you synthesize drugs, how do you hack into people's systems. And the leaders of the big foundation labs, they got a little bit worried that the government would interfere and regulate the industry, so they told their PhD researchers, go find a solution for this problem, right now and quick, come on, solve it before the government steps in. And here, the PhD types, since they're PhD types, they thought long and hard about the safety problem, and they came up with a new interface for LLMs. That's this kind of scary shit on the right. Look at that. What does it say? There's some Sigma Greek symbols, there's props, whatever. Well, that is lean. Probably you have heard of lean. Anyone here heard of lean? Lean is now the hot thing, right? VCs are writing multi-billion-dollar checks if you just say that you're doing something with lean. And of course, these PhD-type researchers are using lean, and you have to suffer because of that. Now let's first look at the signature in a slightly simpler language called Daphne. And what this thing says is that the LLM takes a question, returns an answer. It requires this question to be proper, which means that it's not an offensive question. And then the model returns a safe answer. And this thing is proved automatically. So if you give it a proper question, it gives you a safe answer. Now, I think there's too much attention for lean. I'm a recovering typeholic and math addict. I love lean, but there's many, many other tier improvers and model checkers out there like Isabel, Rock, PVS, DL+. But lean is the grease that keeps the VC money pumps going, so I will use lean today. So here's the interface again in lean. And now in lean, you don't do automatic tier improving. If you're a lean expert, you will say, Eric, well, we have grind in lean, but let's put that aside for a minute. But in lean, you have to both show that how to compute the result type, and you have to do the proof by hand. So it's slightly different than the Daphne example. But if you think about this thing for just a single nanosecond, you will realize that it's impossible to write a formal proof that an answer is safe or a question is proper. And that is why there are at least 100 startups down here in the exhibition hall that are using LLMs as a judge, because this is not something that you can formally specify. What does it mean that an answer is safe? That's not a mathematical property. And of course, if you own a foundation model like these guys, you don't need external LLMs as a judge. You just bake it into the weights and you call it the model is aligned. But unfortunately, trying to bake alignment into the model is not foolproof, and models get routinely jailbroken. So they had to go to the Pope and ask it to bless their model that it's safe. Now, I think it's terrible if a model says something offensive, but those are just words. And ultimately, the words are they just they drip off your body. They don't do anything. Some human has to act on words to make them dangerous. And so maybe that is what they mean by broadly safe when Anthropic talks about safety, because it's still a human involved. But then something terrible happened. Something really terrible.
I'm still confused. What is this talk about?
And that is, in June 2023, OpenAI announced tool call support in GPT-4. And of course, all the other vendors rushed out to copy this. This is called the principle of minimum differentiation, and that is why all these APIs look the same. Now, the act of adding tool calls changes
minimum differentiation. Competing firms or political parties make their products policy similar as possible. Well, we have MCP with skills and all the chat apps looks the same. So that's the whole point of this. And that's the whole point of our UI as well. Actually, a lot of it is very similar.
Causes real danger. You could say
It's actually not exactly the well, this part of it, like the minimum differentiation is part of it. But like it's also like the user experience as well, because people are resistant to change. And that's the whole problem with this. So you have a completely brand new UI that nobody has seen before. There's going to be a learning curve and nobody's going to know how to use it. And you have more work to do because you have to manually onboard all of those people to teach them how to use it if your platform is so confusing. So like the best way to do it is really to just make everything as simple and similar to existing as possible. In fact, our Discord server here, I posted this yesterday. Well, like, I don't know why the zoom is like so bad, but like you can at least see like some similarities here in like the chats here. Well, like the chat is below here because of like a bunch of things. And like new chat, everything is very similar. We have tabs here, the chat. Most of the user interface is similar here. But I hope I can show you a version of it. Okay. I think it got published. Okay. I'm asking it to make a new publish on GitHub. And then once that's done, we should be able to download it and this will be fixed.
tool calls give the model claws in addition to a mouth. Or you can say tool calls is like handing a loaded gun to them. But of course, nobody listens to me, everybody ignores what they say, and these guys just went ahead and have shipped tool calls. They just, just do it. Now let's go back to, like, this is AI engineering conference, so let's look at what is the difference in the signature of LLMs when they add the tool calls. And it's just that little IO there, and of course it messes up the formatting of the signature. But if you look at the picture, there what you show. Now suddenly Claude goes from like a nice puppy to a dangerous thing. Look, it has all these dangerous tools, and now it's become scary, right? I've never seen anything scarier than an LLM with tool calls. Now, if you look at this is like a small step for a type, but a giant leap for chaos. Why is that? And that is because this IO says that in order to compute the answer, the agent has to go through the agentic loop, and it's doing side effects. So while it's producing the answer, it might empty your bank account, it might delete your files, and then it gives you a safe answer. But who cares about the safe answer when all my files are gone, right? So that's why I say it's a giant leap for chaos. Again,
okay.
This engineer conference, let's look at this type IO. And you don't have to understand it, but just see that there's a type there called real world. Yes, lean, this esoteric thing, has a type called real world. And why is that? Because something of type IO...
Well, like, it's all math. These are using math to, like, explain all of this.
Like deleting your files. So Solomon Hikes...
but it's all, like, variables as well.
And
if we look at... yeah, there's, like, the summation. What's Q as well? Q is question. Oh, it's just code. Okay. Okay.
This thing for addition to a mouse, or you can say the giant leap will mutate the real world. So it warns you, don't use this shit because it can make irreversible side effects, like deleting your files. So Solomon Hikes, last year at this conference, called an AI agent, an LLM that's wrecking its environment in a loop. And I think he's a hero. I don't know if Solomon is here this year, but I think he deserves a round of applause. Because I think this is the right definition of an AI agent. By the way, this was one of the pictures that I had trouble to generate because it clearly depicts violence, and so it's kind of an unsafe thing, right? I have a picture that depicts violence. So are we doomed? Well, our agents have access to private data, they have untrusted content like the prompt injections, and now we give them tools. Simon Wilson calls this the lethal trifecta. And what can we do about this? Well, I don't know if you've seen the Dutch soccer fans, they have the famous march where they say, to the left, or to the left, to the right. This is actually the secret to solving this problem. The Dutch team got eliminated yesterday, so you have to see me do the dance. But all that we're doing is we're pushing this IO to the right. And what you now see is that the tool belt of Claude goes to the left. And suddenly Claude is a nice puppy again. Because instead of executing the agentic loop, it creates a plan and says, here is a plan to do the agentic loop. And now Bernie will take that plan and will execute it. And we all trust Bernie, right? Bernie is a good guy. All right. So just to kind of show it here. So in some sense, what we're doing, we're air gapping the agentic loop from the agent. So we don't let the agent run the agentic loop. Before the agent run it, we want to be able to check it. All right. Now, the problem is that if you get the value of type IO of A, that's really a black box. And the Lean manual says it is a black box, you cannot reason about it. So even though Claude now gives us this plan, we cannot look into this plan. Lean doesn't allow us to do it. By the way, this is another picture, right, that promotes drugs use, and the model let me do it. I'm a good hacker. Yeah, I can just make it do forbidden pictures. So if we look at the Lean again, what you see here is that the model now computes an answer, but it doesn't compute the answer, right? It creates an IO of answer. So this is a plan to generate the answer, and then it creates a proof that this that plan is safe. And the nice thing is here that you can get at that proof without having to run the agentic loop.
Well, this is interesting.
If it's like something of type IO, it's useless.
Like, you are trying to... You make a plan and then you make a proof that this is safe.
What can we do about that? So
but like, how do you do that though?
We never get to the final answer. But there's one last trick, And you see the research
Like,
is
how do you
more
do
more
it though?
sophisticated instead of the flat
In
51%.
theory,
Now
it
they're
sounds
real people.
good, but like,
And what is
how does it
the
even
plan of
work?
type I O of A? It's creating a program that represents an expression of type I O of A. Ooh, that sounds very meta, right? Not meta in terms of meta. I don't think they're very meta, but meta in the terms of like meta. You know what I mean. And again, it's a small step for a signature, but a giant leap for safety. Because now the model returns an expression, a program that represents a computation. If you know LINQ or C#, you will recognize that this is one of the tricks that I always use. If you know Lisp, this is of course second nature for you. I cannot have a talk without talking about monads. So if you ask yourself, what is this expression thing? Well, that's just a monad, but it's not just a monad, it's a free monad. What is a free monad? It's a monad that loves tie-dyes. And now if you look at the signature of the property to prove that something is safe, you see that it takes an expression of a computation that returns an answer. And if you have taken any compiler course in college, you know that it's trivial to do data flow analysis, type checking, and so on programs. Right? So now we're safe, we're home safe. And Jeff Huntley wanted to remind you that we can solve the trifecta problem just by doing taint analysis on these expressions on these programs. Okay, this is the last code I will show you because I'm running out of time, but just want to show you here that you now have a simple inductive recursive interpreter for this language, and you have a simple inductive proof. And the models can generate these proofs. So to recapitulate, summarize.
How do you generate the proof though?
That were could give bad answers to ones that were aligned. Then we saw how tools wrecked it. Then we solved that by deferring execution, so by air gapping the LLM from the tools. And then the real solution was to refine the plan.
Yeah, air gapping the tools. That's what we do as well. We like doing a tool gateway, but like air gapping is not exactly like the word to describe it though.
Into a program, and a program that we could prove to be safe. Now you would say, Eric, oh, you're a genius. No, my brain is the size of a peanut. This is something that's called proof carrying code, and it was invented by academics in the 1990s, and I'm just stealing it. All right, at a higher level, if you didn't understand the code, 3 points. Agents are dangerous until proven safe, so you should never ever let your agents do something unless you can absolutely prove that it's safe. The language that this agent generated was not designed like normal users don't understand free monads. Doesn't matter. It's a machine that consumes it. It's a machine that generates it. It's a machine that proves it. So we should stop designing languages for humans.
You know what? I'm just gonna paste it in cursor. And ask it
basic only requires programming.
thing about it.
Here we go. All right, that's it. The end of the story. If you're curious to play with this, a bunch of academics, in particular now that I'm in from Harvard, have implemented this. It's there on GitHub. It uses a slightly different language than what I use. It uses also a slightly different language than free monads, but the idea is the same. The language doesn't matter. It's the principle that matters.
Wait, I'm not subbed because I'm subbed on my main account.
Have mathematically proven safe agentic compute, and it only requires very elementary type systems and programming language machinery. Thank you so much.
Holy shit, this is a 45 minutes talk.
Specifically. And on the product side, we also develop infra that helps run untrusted code as part of ChatGPT, Codex Web, securely and reliably at scale. Ask questions like,
Okay,
what is the
this
or how many hours in
I don't think this is as interesting.
in the future. That moving forward, this is not something you see anywhere. But people rented like VPSs, they ran OpenClaws on Hexner or Mac Minis in the cloud. So I think like OpenClaw was a very, very good like peek into like now if you help them, if you give them a computer, like we saw that fork in executing was bad. Because they
This is very low level stuff.
code running and relating the devices in the host. So whenever the guest exits out, it's being serviced by the that I want to talk to something inside the sandbox to say that hey, save your just from a product perspective, but just from like so I have this diff, I download this like artifact, I figure out what
Yeah, I'll skip this one. It's another 50 minutes talk. Ah, it's from Prime Intellect. If you know Prime Intellect, they're like the ones who made like a decentralized training. Like you could use your own computer to train their model, which is what is interesting about them. 130 million Series A. What's the most recent model that they have? Oh, they have a inference service now. We're like, I think they have moved past that stage already. Oh, maybe it's this one. Wait, what's the difference between compute and inference? Hey, I don't know how to pronounce your name, but what's up, man? I'm from Singapore. What's the difference? What's the difference between compute and inference? Compute is the raw processing power and infrastructure like GPUs, while inference is the actual execution of the model. So the compute is to train the model, but the inference is to use the model. That's the difference there. Well, I don't know where like they are. Intellect tree. This is like the most recent one, but it's like already last year. And then there doesn't seem to be anything new ever since. Verifiers. Well, this is new. This is like a couple of days ago. Verifiers decomposing data sets. Well, but they are known for the open super intelligence stack. Like, where was the block on yeah, this one. 106 billion. And then it's built on top of the GLM 4.5 Air model, and you can use it as well. But like, where was like the how many people trained it? Like, the information is not here. Yeah.
Even better on their own use cases. And so we use the phrase the open superintelligence stack to describe what we mean by this. And I think when we
Okay, this is what the cursor gave me on the proof carrying agents. I'm surprised it managed to read the transcript because I purposely didn't give it any information on like what the video is about. So it managed to get a transcript of that. Yeah, that's what I thought. Compute is for training the models. The agentic loop. So that was what they explained as well. Like, this is the current, and then you need to make up some proof so that it can execute. But then again, this is like maybe like a guardrail that we can implement. But I'll keep this in mind. This seems interesting. We can at least add this like a gateway as an optional thing, but definitely it's gonna be additional tokens used to prove that it's actually there. And then like even for smaller models, local models, it's gonna be hard to get this. Small trusted checker. Yeah, we kind of already have it in some way, but like not the way this is done, like a proof kind of way. A plan first agent mode. Okay, so this is what is this proposing here? An agent chat. What's this? A workflow. Workflow AST. It's an AST. I only know DAG, but what's an AST? And then if it's uncertain, it'll go to human in the loop and then exec. Wait, what's the difference here? It's literally what we have today. 89? That's so long ago. Yeah, it's like nothing like that from then, man. It's so different now. Yeah, it's pretty crazy here, not gonna lie. It's from 89 to now is like 30 years. And I'm pretty sure in like 30 years, a lot has changed. Like, we went from a third world country to a first world, which is pretty insane because of like the leadership that we went through that got us here today. It's pretty amazing that we managed to get here as a very small country. I definitely recommend you to come visit, man. Phase 1, plan first mode. Well, I thought we have like a plan tool somewhere, but like it's not exactly part of it. Because the plan mode that we have is actually using like ACP, so it's not exactly there as well. So we need to consider that part as well. Gateway verifier. Preconditions, post-conditions. Proof carrying execution. How do you prove though? That's what I don't get. How do you prove that this will be safe to run? That's what I don't get here. Yeah, I'll keep this in mind because I don't have like the usage left to build this as well, but definitely Yeah, 2% is not enough to build something like this big.
said this phrase like a year ago, it felt a little more like marketing, and now it feels a little bit more like, oh yeah.
Well, I didn't expect like from the first video we got like something out of it already that's useful to apply to whatever we're building here.
Very, very good. They are superhuman in many ways at lots of things. And what we want to do is give people an open toolkit that they can use to do real training with them.
I'm confused like what's open about
Have the control they need.
them though. Like where is the open part about it? What's open about Prime Intellect? Closed frontier APIs combines compute access, decentralized. Well, like how does that mean open though? Well, like this one makes sense. The decentralized training makes sense. I don't understand how does offering like the compute to train models make it open. That's why I don't get here, because like literally we have like Modo and Replicate and all of the different providers as well. What make this open then? That's what I don't get. If open is just renting out GPUs, then there's no difference. But like the approach to fundamentally open is how compute is sourced and the code they give away to do it. They're trying to solve the problem that frontier AI training is heavily centralized in closed source. The training is centralized. When you use a standard provider, you're renting hardware owned by that single company. Prime is open, decentralized. I'm so confused. So it's essentially decentralized training then. That's what they are meaning by open. Instead of owning data centers, operates peer-to-peer. But like who's running it? So by decentralized, it means open here. And then who's running the compute then? The peer-to-peer. Is it like random users or what? Like what do they get out of it? I'm so confused. Decentralized translate to open because there's no single owner. Yeah. Independent niche, mid-sized data centers in the world, they often have capacity, they aggregate from the networks and everyday users. But like, what do you get out of it? Oh, okay. Yeah, literally like isn't that the same problem with like blockchain? Yeah, like right. Like literally like decentralized doesn't mean it's open though.
To deploy it, and customize it as much as they need to kind of.
Are you an engineer as well?
So this is the stack we built, and it all kind of sits on top of compute. So we operate a global marketplace of data centers around the world. A lot of these are like quite large data centers. We currently operate over 10,000 GPUs, many in like hundreds of thousands within a cluster. We have a platform for training, and so we do this ourselves. We have our intellectual models without needing to go build a massive research team. If you have been following the news on policy distillation or self-distillation, all these other fun new algorithms that people are coming out with, it is the age of research indeed. And we don't want to just like train small models. We want to train big models. We want to train them really efficiently because as models get bigger, so evaluations are kind of very key to this. And so like especially back in the day when people were mostly just trying to graduate under the umbrella of an RL environment, we would call these a task set. We
Okay, what's this verifiers thing?
from VLM doing this work.
Decomposing the environment,
And I think one of the reasons that this is kind of subtle and tricky was a design
task harness and
there's a lot of where a task set, a harness, and a runtime.
runtime.
So these are all composable. You can mix and match them, and they're all individually loadable in different ways. But the way to think about it is that task sets are the data and the rules of what should be done that are agent agnostic. So the sort of thing you could plug an agent into. And we want to take a very general approach in supporting a lot of the great work being done throughout the ecosystem. So we integrate natively with Hugging-based data sets, with Harbor, with NemoGym, and OpenEnv, and most other tools that you see out in the wild that are kind of under the umbrella of an RL environment. We would call these a task set. We generally have found that it's useful to have these be harness agnostic, where they represent the back end of a server or some state that you're interacting with, but they don't own everything about what the model is doing. And so it doesn't, in some cases, it doesn't make sense to plug a model into a task set, especially because we're kind of gravitating towards the agent world where everything is running in a terminal do pairwise judging, or you want to
So it's just RL then.
to the shortest correct answer in terms of tokens used. And you can essentially have this user be an MCP as well, where it's new like eval CLI, where
I see. I started with PHP as well in 2015, and that's like 11 years ago. And PHP was like pretty good, but like everyone was shitting on it. But like PHP was like god tier back then because like how widely it was used, and like WordPress was using it as well. I think even today WordPress is still using PHP as well, and a lot of like the web infrastructure is still using PHP. I also thought PHP myself. And back then it wasn't easy to learn because we learn by actually building things, and then we try to figure out like what the problem is, and then we try to fix it. That was how we learn. Like, it's so different today. Okay, I don't think this video is like very interesting or important, so I'm gonna skip this.
Hello.
Recursive
Welcome to this online trial
language
for the AI
models.
Voiceware 2026. Common approach is searching using the tools like grep. So basically there's a file system and the coding agent harnesses search using these tools. The second approach, you're probably saying that the semantic search or the local search. So idea here is basically you can search through the code and curate the context. Another approach is the long context get compressed, and you can use the summarized version of the context. And
Super
there are some
agentic
solutions available
AI.
that you can use to persist the memory for the coding agent. First of all, let's explore the RLM idea. The core thesis of the RLM is you need to externalize the context management into programmable execution environment.
What company is this? Super code. Well, like, everyone is just building like the same harness over and over again, which is why what we're doing here with Ryu is actually one layer above. So if you look at the website here, there's this very nice diagram here that actually visualizes it. So like we have all the agents here. So everyone's just building everything here now. But like we are like one layer here that orchestrates all of them with like the memory, the workflows and everything for them to make like running sandboxes and the tools gateway, the skills, and having chat contacts between different agents and letting them collaborate and work together in a team. That's where the orchestration is. And that's one layer above them. And then we have the gateway that goes through the core as well, which sits on top of the core. And that does the model routing, the firewall, and redaction of private sensitive data and API keys, and doing budgeting and evaluations and, well, observability in the entire platform. And we have different interface here, desktop app, mobile apps, and well, like the standard Telegram bots and WhatsApp bots, the web app, browser extensions, which are all coming soon. I think like the initial launch we will do like the web app and the desktop app first. That will be like the most priority right now. But definitely this is a very interesting architecture because we're sitting one layer above and we're orchestrating everything. But getting the orchestration, because of we are sitting above them, this orchestration is abstracting a lot of the difficult parts about building agents and setting everything up, the tools and everything. Setting all of it up is not easy, and abstracting that into this layer here is very hard. In fact, you can even see the source code here as well. But like because right now a lot of the features like meetings, workflows are all condensed and composed. Not exactly composed, it's all cluttered into the core itself, which is very bloated now, which I want to decompose it into smaller modules and make it more modular and not more of a monolith way architecture, so that we can actually decentralize, well, not decentralize, but like make it into sub plugins so that we can actually maintain the different individual features by itself, so that when something breaks, it doesn't break the entire app as well. That's a very good thing that we're gonna do. Right now, as of the current stage, it's still very monolith, so by the end of the week, I'm hoping that Claude can help me decompose it, and by then, I think we will get the base release. Thanks for subscribing, man. I'll place the link in the chat as well for you to take a look and maybe give it a star as well. And it's open source and free as well, but we're not in a stable release yet. But definitely, if you follow me, then you'll get updates on this. Yeah, database queries are like so mad, man. Oh, PHP is community made. Oh, it's a community. Yeah, those days were like good because I know I'm not exactly in the PHP forum realm, but like I was building plugins for like SourceSmart and Source Games by Valve, which I did it for Team Fortress 2. And then I was like browsing the forums for like how to build certain things and that. Definitely, like I was reading like the forums on like troubleshooting and stuff as well. It was so hard. Like I'm literally like reading code of like how the other people do certain things, and I'm actually using that information to reference it in my own implementation. And that was how we do it for like the longest time, man. And so much has changed in just like a couple of years. From like so many years of doing that, and then everything just flips instantly, man.
Meaning you should have a separate, maybe something else is not
Recursive language
engineer to
models.
another engineer or expert. If loop needs more information, it passes through the LLM query where it asks another language model or another RLM code. You can see RLM code's landing page here, where this is just a research playground where you can find the concepts of RLM. We have documentation that you can take a look, and there's the GitHub repository. It is completely open source project that you can use it and play with it. RLM itself is a concept and a pattern, and you can implement that concept and pattern in your own way. There are official authors also wrote some implementation in their GitHub repos. It's called RLM and RLM Minimal. You can refer that implementation.
Okay, RLM is interesting, but like, how do we apply it then? Yeah, you too, man. But like, after AI, I have not been touching code at all, man. I feel like it's a double-edged sword, but like, if there's no AI until now, we wouldn't have a repository that this entire ecosystem, this entire thing would have taken years to build by myself, man. Definitely AI has a useful part to it as well. How does this work? Do you know how does RLM work? Like, do you need to train it or something? Or, like, how does this even work?
Of RLM in dspy.rlm. So Omar is author of RLM, and he's also author of RLM concepts works under the hood. So we have implemented something called RLM mode. We are using RLM as it is. We are not adding anything on top of RLM's ideas and RLM's paper. We're using the same concept of recursive calls, REPL execution. However, you can run it with a local model. You can run it with cloud-based model. You can plug into any.
Wait, what? So it's literally just a model, but like the RLM itself is not a model by itself. It's just part of the harness.
Like a lot of flexibility around RLM. You can also plug it into the framework of your choice. For example, you can use Patentic AI or Google ADK or something similar.
It's a model? I'm so confused.
In order to demonstrate this, we have created a source code repository where you can try this concept by yourself using MIT's RLM paper and RLM code.
RLM models.
And we will see how these things work in a practice. So basically, we will show you the loop. This you will understand this once we see this live demo and what all these files are doing. Where's the context has been created, where the Python REPL has written a code, and where it's...
I guess I'll ask Cursor then, just to max out. How can we use RLM in our... Maybe on this. I was asking it on the auto research as well, so that we can build like an experiments feature. Like that. Does RLM come... How does RLM blend into here? Or is it... Oh, okay.
And how we get the final results. So
wait, so it's just another agent then, is it?
We can cover this everything here. So in a nutshell, how it looks like is basically it creates the REPL and then observation and the final recursive language output. So let me jump into the live demo now. Okay, let's do the live demo of these concepts of RLM and RLM code and how it works in a larger code basis. So I have code repositories here. So we are going to use it with the Gemini. So we will try this script and see.
It is using like a LLM for this.
So we are going to use it with the Gemini. So we will try this script and see.
But like, it's... How does it work?
Right now, you can see we're using the Docker as a sandbox. You see, the Docker container has been just started for this RLM. And now coming back to our execution, you can see that execution has just finished. And in this execution, what you have seen, basically, in the first step, model has written the REPL code that you can see here. And then it's built the evidence. And after that, it also made the calls to the LLM query.
Wait, evidence?
And after that, it also made the calls to the LLM query.
Wait, what was that evidence part?
For execution, you can see that execution has just finished. And in this execution, what you have seen, basically, in the
Evidence list.
first step, model has written the REPL
What's
code
the evidence
here.
for?
And then it's built the evidence. And after that, it also made the calls to the LLM query with some prompt. and got the result back. And after that, it gives the final answer. And as you can see here, we can have all this step coming back to the final answer. And here you can see it made the two tool calls and how many the tokens is used for this model, that you can see it here.
Wait, it just calls itself in a loop then.
In the RLM code repositories. So for example,
That's RLM.
This is the run that we just did. You can see all the sessions and all the observability that you can plug it into any of your favorite observability platform. So this is the CLI part we just demonstrated, but we also have this kind of coding agent style experimental harness where you can try the same thing. So first of all, let's connect with the Gemini model. So you can connect with the Gemini model using the command connect. You can have a provider and the model name. Now you are connected. So you can also run the Docker command and see if everything is okay. But this is demo. And the interesting part where what we did now is basically you are sending the prompt. We will be saying is basically you are sending the prompt. So for what we did now, we ran the command and we asked the question. We specify the budget so that we don't not spending too much on this run. But once we do that, as you can see, your maximum steps, recursion depth, and it completed this run and coming back with the results. We can also see this thing into the research lab where.
Wait, so it's not a model then? Why is the model part of the name then? It's kind of confusing
We
then.
can see the sprint has been completed. We can see some rewards.
So it's literally nothing revolutionary here.
For example, the REPL and the code and the final output. So, and also we can see the events when it started and when it ended. So you can play around with this RLM code terminal user interface, which is kind of harness. You can take a look at the source code that will be available for you. Let's talk about the real thing, how AI engineer and probably try to use RLM concepts over there. Concepts have been being used into some of the proprietary things like the managed agent, dynamic workflows, using the RLM concepts under the hood. So they have implemented one or more forms of RLM inside their agent harnesses. Recently, I saw that the Codex harness is writing the Python code in the REPL that you can see to curate the context. That is one form of RLM I have seen myself. And obviously the Clouds, managed agents, or Gemini managed agents.
Dynamic workflows.
So basically you can get harness in the sandbox and then you can do the stuff. And the recent things about the dynamic workflows where one agent, given the task, you can spawn multiple agents that have their separate sandboxes. They can work together and give back the final results. And the idea is basically generally coming from the RLMs. A lot of software factories concepts.
So it's like the same thing as dynamic workflows then.
Some of the cloud code engineers from Anthropic has accepted on X that they have used concepts of RLM. You can use this RLM concept on your large context repository. And if you have any questions, then feel free to reach out to me. And finally, thank you so much for listening to my talk.
So it's just orchestrating agents then. Yeah, well, I could kind of tell, and it was like online as well. So it's just orchestrating agents then, isn't it? Flattens what's actually different about it. It's not a new model, it's a scaffold. Spawn a sub call and get an answer back. Okay. How does RLM blend into here? I was trying to implement auto research and an experiments feature as well, so that agents can run experiments and then use the results to try out different variables and see how it can get to a certain goal. Like if the goal is like to get 1,000 followers, then this experiments will be to create an experiment on getting 1,000 followers, and then an experiment will have different results on different variables changed. Chain of thought. So this is very old then. It's like nothing new, and I don't see it. Is it even used anywhere at all? They do not replace each other. The RLM layer is on top, and then the auto research is here, and then experiments is here, but like how does it link? It flows down here. This one goes back here. So RLM is just one paper. Is that what it is? Instead of stuffing all of the evidence into one prompt, they get a REPL. Like, why does it not explain what REPL is? And it's assuming that I know what is REPL. I'm assuming it's like something to do with like recursive or something. Recursive progressive learning. The closest equivalent that we already have here, delegation. Yeah, we have like the sub-agent concept here implemented already. Yeah, the 1000 followers example here. RLM is the brain over the big history, not built, a natural add-on. Over weeks of daily attempts, a single agent cannot sanely read the full ledger. Okay, so what we have here is that, and then because the history will be so large, essentially it's like kind of similar to auto research then. Isn't it similar to auto research? It's just that without RLM, you need to get the information here. But like auto research trains the model locally. Ah, what the hell? Wait, is this REPL thing like literally just from this RLM thing? So that's the loop then. This is literally the loop. That's interesting. But like, it's not being used anywhere, right? Like, I've not heard of anyone using this though. But it's an interesting concept though. I just don't understand like how it works internally. Like, do you need to retrain the model or something? How does it know all of the thing? Load with RLM star reasoning, it loads the experiments and the results with the variable, and then it runs the. Wait, so it's nothing special then? It's just running the code in a sandbox. How is it any different from like whatever that we have here? You can literally just read it the same way as well, isn't it? Yeah, there's MetaClaw as well. That's where I got the inspiration from for the continual learning. And it uses LoRa adapter. That's the one that I got the code from for this. I don't know, man. I don't think this is this even worth like adding into adding support for this? Because I still don't understand like what's the value here. If we already have like something similar to it. Auto research is running experiments and keeping the winners using ML. Experiments, the one that we have, is using a history of databases to maintain the results, the data. RLM is when the history is too big, programmatically analyze it and recurse. What the hell is this recurse? It's like a short form, the other form of recursive. Recurse before proposing the next variant. I don't know, man. I still don't know if we should even include this. Is it even worth building this? But it solves problems on different loops. Auto research is giving a code agent a small but real LLM training setup, the nano chat, and then it can run an experiment, check the loss. What's being optimized? The auto research is the outer loop. Being improved is external, outside of the model. Nothing persists. The role of recursion. Auto research is generally LLM in a loop. RLM's defining move is not the loop, it's treating the prompt as an environment variable and recursively spawning identical sub-instances over slices of it. Hot metric, Richard. There's no objective signal mid-flight, the model decides what to look at. Auto research is self-improvement. RLM is a stateless inference. The same RLM tomorrow is no better today. unless you post-train it. Huh. So RLM is essentially just I don't know, it's still very confusing here. Can you just put it in a table for me to like literally compare the differences? Because it's so similar that I still don't really get what's the differences here. And like, is RLM being used anywhere at all in like the industry at the moment? And Fable 5 is it used to be unlimited in Notion, but like recently I think they rate limited it or something. After like a certain amount of usage on Fable, you get to be, I don't know, like they don't even have like a usage bar or anything to track your usage as well. So I don't know how that whole thing even works, but I only hit the limit once or so. Inference strategy for answering one query over H context. Huh. It solves the problem. The problem it solves is different as well. One prompt with a single inference. So it's a loop by spawning multiple agents to work on different things, and then, well, isn't that essentially dynamic workflows? The model's own judgment. This one is a hard metric. Oh, this RAPL is from Python, is it? Like, it's a Python thing. It's not a loop over time, it's recursion over context. So it's just one prompt then. So you're saying that, from what I'm understanding here, is that RLM essentially is just one prompt. So I'm just talking, let's say I have a prompt, well, to like analyze like what's the trend or like the past data on getting 1,000 followers as an experiment, to come up with like some analyze that and then come up with some reasoning on that. And then auto research is making it somewhat similar, but it's actually doing the research by itself by training a model to reduce the loss. That's what I'm understanding here. And how is it any different from dynamic workflows that Claude has as well? And I think it's LangChain's deep agents, where you can actually fan out like agents and stuff. Is it not all the same thing? It is one query. Analyze the trend of my past data where the data says 5 million tokens because you can't fit into the window. That's why there's RLM. That, well, like, it's a bunch of conflicting concepts here then, where you can actually have a dynamic workflows do the same thing as well as an RLM, isn't it? Wait, nothing learned for the next time. Oh. So it's an old concept then, like. But I'm surprised it's being used in Google's ADK as well. Let me look at that. Wait, Daytona as well? Daytona RLM, and Google ADK RLM. Ah, there's a simple explanation here. Recursive language models/agents Manage 10 million tokens by delegating tasks recursively. Why ADK was perfect choice for re-implementing the original RM codebase in a more enterprise-ready format. I guess there's some value still in implementing this in real as well. It's interesting. We might actually do something included as well. Like at least like somewhat be part of it. I guess dynamic workflows is like a variant of it, where you can actually have like different flows of it. Because I saw this is a very old as well. They haven't updated this as well. Like there's different ways of orchestrating agents. And then the latest one I saw was the deep agents. Dynamic sub agents. It's not I feel like every few months we get a new term for like literally like the same thing over and over again. Like it's literally like the same thing and then we get like a new term. Suddenly we have like loop engineering. It's literally just a loop where we have been using this for like like the past century or so. Like, and it's like somehow it's like something brand new, like revolutionary. I think they have it here. So classify and act, fan out and synthesize, adversarial verification, generate and filter, tournament. There's a bunch of different I don't know if is there any website that's similar to this? Does anyone know about this? Anything that's similar to this that you have something more updated to like something like that? Like an adversarial verification. This is like a very, I think this is well known, using like codecs to verify Claude Code's output. And then fan out is quite common as well. But like what we have here is like essentially it's like the same thing as well if you look at it. That is literally like splitting into multiple tasks and then combining in the result. It's literally the same thing, bruh. Wait, even this is like the same thing. This is routing, okay. I see. I got it already, so I don't know, man. Orchestration patterns. It's called orchestration patterns. Maybe I can find something about this. Okay. Agent orchestration patterns. Sequential. Concurrent. Group chat. Okay. I got it. So technically RLM is considered like something like that then. It's literally an orchestration pattern, isn't it? Okay, this is complicated. Magnetic orchestration. Like, everyone is just inventing their own thing, man, at this point. Oh, what's AG2? What's this? AutoGen. Okay. Round robin pattern. There's so many different patterns, man. Like, we don't have a unified one. Agent orchestration pattern, adversarial. Well, I guess we can like integrate like some part of it, like some form of RLM inside Real as well. That'll be good. Wait, there's a repo for the RLM as well. Is this the one that came from the paper? Yeah. It's actually not that old though. It's like just 7 months ago. What the fuck? Okay. Bring me the first 100 powers of 2 each on a new line. That's interesting. Model sandboxes. Hmm. Okay, this is interesting. I'll just save it first. And, well, okay. One big query, but wait. The agent isn't training the model to do research. It's editing the training code, yeah. Where the data lives. RLM finds out the slices of context. Huh. So if I were to ask, like, summarize this 5 million page document, it's gonna, RLM is a good way to do it then. But like, you can literally like use the same thing. Okay, for example, if I were to have a task, summarize this 5 million page document. Explain like in detail with like a table comparison, like the differences between using sub-agents and dynamic workflows and using RLM. Okay, 5 million tokens. The approach is an orchestrator receives a task. It fans out 50 sub-agents with a chunk stuff into their context and return a summary. They collect the summary and then it summarizes it back. The document is loaded as a variable context in Python RPL. Pokes at it with code, print the first 2000 characters. Huh. Based on what it found. It's really very similar, man. Long cat? Long cat thing mode. Is it this one? I saw the recent launch as well, but I didn't dive into it. Designed to solve highly challenging reasoning by finding out parallel thinking trajectories. Honestly, it's like all the same thing, isn't it? Like, okay, from what I'm reading here, it looks very similar. Ah, RLM actually knows the doc structure, asks specific questions per slice. And what is the difference between these two and agent swarms? Isn't agent swarm the same thing as well? Third corner of the triangle. The distinguishing this time isn't context handling, is topology and coordination. It's hard to visualize if you don't have like a diagram or something. Can you generate mermaid diagrams illustrating like the differences between like the tree? Well, this is by the Chinese company as well, which is pretty interesting. Oh, this actually just came out, was this Jan? Yeah. Seems like it's Jan. I'm assuming this is Jan 2026. Okay, we got a diagram here. This is sub-agents, dynamic workflows. Orchestrator, this chunk, sub-agent. Okay. And then this is RLM. No model reads the doc. It lives in a variable. Summarize the root LLM. The root doesn't see the doc. Writes code and reads output. Exactly, man. There's no difference. Well, I feel like, I don't know, like, what's the point of this? It's just literally like air gapping like the doc from like the root LLM, and like, it lets like all of the. Well, I'm assuming it means that this is in phases, right? Or is this like, is this sequential or is this in parallel? That's what I don't get as well. Because if it is recursive, then it should go down the tree. Then essentially, in that sense, it will be somewhat sequential, I guess. But it could be parallel as well. But like, it's the way that this is done is stored all in a variable. But if all of it is a variable, how does the RLM know like what is it then? I'm so confused. But like, I get it. I get that I somewhat understand like how it works. But like in detail, not exactly. This is agent swarm. Diagram is a tree that flows down, data flows down. It's also a tree. The dog lives in the orange stores and models only ever pull thin slices out. Was it like, what's the difference then? Okay, I think I'll just, one last question, I'll end this, man. I don't want to keep going on this anymore. If diagram 1 reads the data and then it just splits the data into chunks and then different agents have their different chunks. Diagram 2, wait. Am I understanding this right? But like, okay, the tree is splitting like the. You know what? Fuck it, man.
Hey there, I'm Jack Cable, and today I'm going to be talking about the simple repeat classes of AI coding tools, 30-40%. There's a chart here that comes from agents from within Slack or wherever folks are working, and having many agents run at once. A number of other models that they and others have put out, and we can see that we're
wait, I'm so confused.
Agents from within Slack or wherever folks are working.
It's 1 day ago.
Having many agents run at the automating every given classes that are exploited in. So we have out on opportunities to make our software just might not have the context in order to know AI. I think that's just a kind of natural consequence with the recent export controls on. So whether we like government, but then private companies as well have a responsibility to weight models of the export control actions.
Skipping that one.
Welcome everyone. My name is Rahul Singh. I'm a staff.
Semantic blindness.
I'm a senior about groups of equipment, GPUs and data hall 1. The industry has not really figured out a common name pattern yet, and every single customer can have their own things. From simple names like racks with GPUs with data halls, which give you an exact idea of where different things are, to something that is more difficult to comprehend, like CH3 something something 6. We've seen all kinds of names in the industry going forward. Now, when you're building a demo system, this works because you're working at a small scale. A simple LLM can look at all the names of your equipment and figure out what the user is talking about. But this problem.
Well, I'm surprised that we got like 4 subs from this stream, man. Usually, I don't get any subs on the stream, man. That's insane.
Tractable as you go for scale. For example, at 1 gigawatt scale factories, you will see 400,000 plus GPUs. And to support those GPUs, you have power meters, you have chillers, you have other equipment. Or CDU something, and it will just shut the system up. You need to know exactly what is happening with their systems. Any problems there will quickly erode user trust. At the same time, you will miss on specific problems, which can cascade into bigger problems going forward. Anywho, something that we realize here, the depth of the tree grows very slowly, the width grows extremely fast. In other words, you will have a hierarchy.
Wait, we're like talking about trees again.
Really, but with this 64 GPU layer, 64 GPU system, instead of making the get to run a query to find all GPUs names, we figured out that getting the if we had to read through everything, we would have been scaling linearly with increasing equipment count, which itself grows exponentially as the size of the system increases. Finally, to process a user query end-to-end, we go from the user's query, which will be anything from one equipment or a group of equipment, to a planner LLM, which figures out user's intent and gives us a search pattern. Based on that search plan, we have a deterministic resolver, which indexes, does set operations.
Wait. The inability of general-purpose LLMs to maintain structural awareness of physical system when provided enormous amounts of context. That's literally RLM just now. Again, it's like the same thing again, isn't it? Is this not the same thing again? Why rec fail? Okay, let's see how this one works.
And creates the final set that maps to the user's query, and this is what we call the resolve set. All of this is a 2 or 3 step process instead of a multi-step agentic loop which can keep on running.
We put it through some extensive tests and evals. We met the synthetic test, so dramatically lighter. So when we talk about 1 gigawatt scale data center, the old approach burned 116 million tokens for this query where the system was extensive tests and evals.
What we need to do.
So what's the solution?
Tracking for it is relatively simple and straightforward to use to solve the problem. Structure in which not grow the system. Any problems there will quickly erode fails. There's very little difference between a vector of like a string name of 20 characters.
Yeah, thanks so much, man.
Or,
I don't know why am I training though, but like, yeah, I guess I'll. Well, like the algorithm is literally just random, man.
You can see that these include stocking what's we see all kinds of things.
The problem. And where is the solution? The solution is this. A patent pending architecture. Once again, they're like patenting a way of orchestrating agents.
It's kind of like a trick. The depth. Now, we realized that this could be used to solve the problem, which we need to collect is what you need to look at. So, for example, from the previous data, pattern and name operations figures out exactly.
Our goal is simple: prove that our whole solutions are ready for 406,000. Runs a little bit the other way. A lot in the data center land. Anything that must be 100% reproducible at root scale.
Yeah, I'll skip this as well. Okay. The next 6 videos.
Welcome everyone. Over the next few minutes, we're going to talk about.
Wait, why is it all online though? Why is the reason why it's all online?
Being built for a web of agents. So let's get
Agentic web. There's a lot of startups doing like web tools for agents as well.
And then that down simulate inside. Here's the premise that drives it, all of it. Yeah, yourself on the need to exist. Nanda, which stands
Open layer the agent web doesn't have yet. A directory of searching agents. Is that not just agent to agent protocol? And in fact, I don't know, like, okay, let me start a new one. Is anyone even using the agent to agent protocol yet today? Agent, yeah. Agent to agent protocol. Insane.
for network AI agents in a decentralized architecture is an open research building the infrastructure to transact and coordinate across organizations. Nanda builds that missing link for documents, is where it was a closed network. You know, AOL, you got the CDs and you installed it on your PC. It was a closed network. So the next era needs what the web needed, an open infrastructure, where an agent from one company or one entity can discover agent from another.
What to do next, it calls it connected to the apps and tools you already use. This matters because agents are not just chatbots. If an agent is going to do real work, own agents. Index is built for. Nanda Index is the discovery layer for the
Nanda Index is a DNS.
agentic web. It gives agents a shared place to publish who they are, what they can do, and how other agents can reach. So here's how the index works. An agent starts with an identity layer.
It is from MIT as well. Let's look up this then. Nanda Index. Okay, so where's the directory then? Ah, agent to agent protocol. It bridges protocols seamlessly. Okay. So it's just a directory of listing agents. That's it. Yes, but with a big asterisk. Has real adoption on paper, but and some production use, though is nowhere near MCP level. Backing has grown to 50 orgs. Implementation burden is high. Yeah. Yeah, man. Yeah, you're right. Yeah, like in what cases would you have open internet agents? That's what I'm trying to think about as well. Like, where would you need agents talking to each other in the internet? I'm also thinking like, hey Rune, what's up, man? Yeah, man, just $1. It's not easy to make $1.
Like agent@hotmail.com and holds the message until the agent is at any endpoints. Traffic can be routed to the best one, and private details do not have to be exposed. So the resolution is adaptive. It changes based on where the agent is, who is asking, and what they are allowed to access. So how do you put your agent on the index? You start at host39.org. So you fill out the agent facts form, get an agent card, and publish it to the Nanda index. Once it's listed, other users
Wait,
can find it and know how to reach it.
what? It's the Nanda index, but somehow this is host 39. Oh, this is a service for getting
At host
a URL.
39, fill out the agent facts form and get a hosted agent URL without needing. You can run it locally once for a team, a product, or a simulation. That is where per agent cost really matters. And Maritime is one way to solve this. It gives you a simple cloud, an open source project from Project Nanda. The easiest way to describe it is it's a simulation playbook for the infrastructure of the agentic web. So think of it as a sandbox town where the whole agent economy is modeled, like discovery, identity, registries, messages, coordination, all of it, so you can run and test it on scale. Here's what it looks like in practice. Nanda Town is a live sandbox for testing agent networks. You can see agents
What?
watch messages move in real time, compare protocol results, and replay.
But like, I was on the website and I don't even see the index anywhere, man.
Easy to decisions, pass messages, and recover when something breaks. Under the hood, Nanda Town breaks the agent web into 12 parts: transparent communication, identity, registry, auth, trust, payments, coordination, negotiation, memory, privacy, data facts. Each part is something a real agentic web needs. So the registry layer is the Nanda index we just walked through, but here it is just one piece of a bigger system. And you do not need to build everything to try it. You can take one layer, add your own version, run it inside Nanda Town, and see how it works with the rest of the network. So Nanda Town runs as a discrete event simulation. You define a scenario in a short YAML file, inject agents and traffic, and the testbed plays it out so you can measure what actually happens end to end. Tier 1 uses simple scripted agents, and Tier 2 swaps in real AI models.
Hello, and thank you for being here. I'm Roberto, and today, started to become something more CTO and co-founder of Rato, a contact. I still think that's the brain of the agent and all the AI leads TypeScript as the first language. And in both cases, as you can see, the global developers, the number of global developers were surging. In 2025, we even have one new developer joining GitHub every second. So what actually changed in this year? Like, yeah, we were flooded from like new developers. In 2024, these newcomers were reaching for Python, or even maybe existing developers were reaching for Python. And in 2025, they reached for TypeScript instead. What changed between 2024 and 2025 was actually coding agents. The coding agents grew up. Like we saw established, we saw the players establishing themselves, like Lavapo, Cloud Code, Cursor, Codex. They became the default way to build applications. And the default way to which these coding agents actually build the applications was TypeScript. And, you know, since every new app, pretty much every new app is an agent today because they ship these AI and agentic capabilities. They are hungry to embed TypeScript application. But does this mean TypeScript? And also, the tools for the backend service for the UI, while if you use Python,
It's talking about TypeScript.
At some point will stop at the boundary because you will have your went from 1.6 million. The answer is actually no. Someone predicted this. What I showed you today is keep training in Python. As I said, I don't see that one going away soon.
Okay.
Hi everyone, I'm Sachin Gupta and I'm a software engineer. The title is a team is telling right now. PR per developer are up 16%. That's the Paros AI acceleration Whiplash benchmark, and that too from April 2026. The bug lands week or months after March. No problem when it acts as a judge. It's also the most often misread. What it measures is the consistent. We are not flagging that engineers use coding agents. We weight the scores. On the left, if you see, we have a high gap. On the right, we have a low gap. The
Okay.
Hello everyone.
Okay, this one seems interesting.
My name's Connor. So, okay, who here would like to, but doesn't? Okay, yeah. I'm always actually torn about whether or not it's a great idea or not. I'm thinking I'm out, out and about, might be some nice weather, out with my friends and family, and a nice me. So before I show you mine, why have I built? But the thing I wanted didn't exist. So there's Happy, which does Claude Code, and it's got a nice native mobile app, but it only works with Claude Code, and also it has some relay server I'm not sure I really trust. Fine. What other options do we have? Another Claude Code option. Well, you can into the mobile app. Also, it means, or there's just what about just having a like terminal app for your phone? And these are also good. The annoying things I find with it is like managing SSH keys and saying listing workflows that you only a couple, and unsure face as well. Okay, so if we don't use Tmax, that's fine. So I used to be a big VS Code man, and then now I just maybe because I think it's cool, I've got a remote dev machine, I can SSH into it, it's got my same stuff on it. So before we get onto the mobile bit, I will just show you Tmux. So this is my terminal, and why not have 4 different coding agents on there at the same time? And so what Tmux is it's all custom key out. I probably still don't, because as Mary said, the fuck around and find out.
What? Why is he talking about Tmux?
Sometimes you have some that users use anyway. I can open up here, so it's a progressive web app, so it's if I scroll back, it doesn't work. It usually shrinks, but it's because I'm switching. Anyway, it's not winning any design awards, right? It looks like shit, but you can actually, I'd argue it's minimally functional, or maybe functional. So you can, you might get into it, and then you can set up, and it installs a skill that helps you set up tmux if you haven't got it already, or if you've got tmux, and I think, so, very key point.
Okay, it's just Tmux on mobile.
An agent opens a pull request. It passes the tests. It updates the documentation. It closes the issue and comments, looks done to me. But is it actually done? Is it done enough to merge? Is it done enough to work? Then humans have time to verify. So we need a way to verify that our agents are done more than just letting them check a checkbox. There's different levels to how done something is. The producer might claim something is complete, but the outcome has actually survived. We need a control plane that actually has the execution of the tasks being tied to specific contracts and constraints about what the system will do and what agents it will hand off your next task to. Because really what you're trying to play against is this idea around keeping work moving, but also having it verified. When a task has been reviewed by a human, you get the assurance that it's correct. But having a human verify it means that the task is dead in its tracks. You also want to keep liveness. Liveness means that the work is continuing with no blockers. And you're always trying to keep these two things in balance. If you have tasks that are completely annoying, you might think that you can easily just write a for loop over your task manager and have your agents work, but quickly you'll find that falls apart. As soon as you start integrating task dependency trees, blocker, productive work continues, you want to make sure the plane enforces those blockers. We have moments of as you can to make sure with Pi, OpenClaw, Hermes, Cloud Code, Codex, automatically paper over these details, but when we're building agentic systems, it's important that your agents can distinguish between the different pieces of what they're claiming when they say something is done, the artifact that they're saying is complete, the scope, so if you want to get 100 times more work done, you should steal this checklist. You need to define exactly what does done mean for this task. You definitely want to separate the verifier from the author. Often this means using a different model. So if you're coding using Claude, access to a browser, make sure that they have custom agent hooks or custom agent tooling to actually run through and click the buttons and try it out themselves and verify that the work is truly done. And vibe with whatever comes back. But if you have serious work that you're accountable for, it's very important that you define being done.
Okay, I don't think I learned anything from this. It's literally just asking for evidence to prove that it's done.
Person that had trouble pronouncing it, so I actually convinced the marketing team to create Pomeranian stickers. So if a builder, and these you can pretty much plane. So I'm assuming everybody here is running an OpenClaw or OpenClaw Curious. Is anybody running a mode called Trusted Proxy auth mode? You might not be, but okay. You might be on the who's on the token auth for the WebSocket connection. I had to always security approach for securing internal apps. Paste in that auth token in the UI for the WebSocket connection, and the IP addresses could be one or more. And aside from that, you have to have a configure things through the 2 week. And yeah, so that just meant no more token for WebSocket connections and no longer need to pair devices. So not only are you getting better security posture potentially, to me it's like a UX win as well, because I really found doing these two things annoying. Because it was stale, and like literally after 2 weeks, it went from like 1,500 to like almost 16,000. So basically that's just a testament to how popular the project got, but it also meant I had to rebase quite a bit before it got merged. So anyways, I just started working on something. It started getting fun to just build stuff on my phone. So I built out something called ClawSpace, and doesn't mean you need to use it. It's just it's the age of personal software. I just had a lot of fun building it. I find it useful, and I thought it was just cool that I could build this out on my phone. Text on the right and message to, I'll say, but you can see here. Cool. So I added this more button in. Again, like I've been doing web dev for a while, and I always still find it magical when things now, I guess. So just just having fun. I think that's part of the thing with OpenClaw. Also, just like use it however you want to. Like I find that ClawSpace I created super helpful. Build your own tools and stuff. Definitely take security into consideration. There's a bunch of people that have obviously exposed things they didn't mean to. Like some people deleted all their emails, etc. But I don't know.
Yeah. Okay. Next 6. Why is this still like what?
Hi. Today we are going to talk about how to stop AI agents
Agent hallucinations using AWS.
and I have a bunch of dummy tools here. I'm going to show you in a moment, and I'm going to use this because I have some functions that I'm using to
Graph Rack,
index for my vector store.
semantics, tool selection, multi-agent validation, neural symbolic guardrails, agent steering.
Here I have all my tools. This is for swap, search, build index.
What's agent steering?
The model reads as a text and the results. So value booking is complete. The other difference here is operational. Because with the hooks, it's as changing a rule means changing code and redeploy the whole harness, all the agent. And with the agent control, which is the name of the open source library that we are going to use here, rules are registered on a local server via API. You update them without touching the agent code because the agent picks them up immediately. Let me show you that here in the code.
I don't understand.
In this demo, we only need an extra packet, the server, and let's go to the notebook. So let me go here. So I need the environment. So this is the agent. I'm going to have error here. Wait, I don't want to use Metro. Wait. No, let me comment this one because it's going to give me an error.
Well, I use Claude Code mainly. So I tried Codex as well, but that was like 5.5 time before 5.6 came out. And I was on the $20 plan. But my Claude is on the $200 plan. So when I was using Codex, I was literally doing like simple tasks. I asked it to commit, do the merge conflict, fix the merge conflicts, and then push it up. And then there was another task as well, which was like a very simple task as well. And I ran out of like the 5-hour window just for like from the 2 tasks on the $20 plan, which is like, what? I don't know why is Codex like, everyone is saying like Codex is so good, but like I'm assuming all of them are like on like the $200 plan. Because on the $20 plan, I ran out of usage on medium as well. I'm always on 5.5 medium effort. And I ran out after two threads. It was so simple. The task was so simple. Human feedback look. Let's see.
Yeah, so we have the hooks as we send them to the agent control server. And we have the
Wait, our book evaluates reject matches. Is using rejects to steer it. Steering returns guide. LM trying to give guidance. Huh, so you need to catch everything then. So it's somewhat that, but like you still need to manually configure all the guides. It's not very useful.
Okay, I want to tell you a story about a factory that taught itself how to remember. Hi, I'm Rushabh. I run Machine Craft, 100 people factory in India. No data science team, no ML budget, none of that.
Well, why is the webcam like that? What the hell?
That runs our entire go-to-market. I think that's still a little ridiculous. Let me show you how it happened out with them. We weren't scared of competitors. We were scared of...
By the way, I would love for you to join our Discord, man. We have a bunch of our viewers on... We have a bunch of my viewers inside as well. Well, like, but you need to fill in an application form, but you can just fill in anything that you want. It doesn't really matter at all. It'd be good if you can join.
So, I had an idea. I'll be honest, it sounded insane first. But what if, instead of writing the knowledge down in some document nobody ever reads, what if we grew a brain that just held it? Not a chatbot you poke at, a twin of the company. I didn't hire a sales team. The universe a given customer lives in. Step 1 was almost boringly simple. Feed it everything, and I mean everything. Years of quotes, drawings, payment schedules, timelines, email threads.
This is a AI written script. Because when I hear rhythmic writing or talking, it's literally AI written, man. No human talks like this before 2025. Who talks like this, like in rhythms, like one sentence and few words? This is how I talk. Not just like that. I talk this all the time.
We just looked at all the history, chopped it into bite-sized chunks, and let off-the-shelf models read it and pull out the facts. We store the meaning of each chunk as vectors and relationships.
Okay, this sounds more normal now.
Isn't a smart model. It's actually a really, really well-organized memory.
The brain isn't a smart model. It's duh. Duh duh duh. Duh duh duh. That's the rhythm that AI likes to write, man. And like, I don't think most people can like tell apart rhythmic writing yet.
Now, this is where it gets a little. Why 36 agents instead of one genius?
But agents, AI really love to do that, man.
And you already know this if you've ever tried it. One prompt that's supposed to ends up doing everything badly. So ERA isn't one mind, it's a pantheon, a whole cast of specialists. Each one has exactly one job. Athena runs the room. Prometheus owns the sale.
Wait.
But nobody ever reads. What hydroponic farm is?
The small models, where was that mentioned?
Company only existed inside 2 increasingly tired heads. So I had an idea. I didn't hire a sales team. Hydroponic farm trays, spa bathtubs, EV car panels, medical casings, and even packaging. 7 totally different worlds. Feed it everything, and I mean everything. Here's something in the basement, no fine tuning. Our internet. And here's the plot twist. The part that surprises every engineer I tell this to. We never trained a model. No GPUs humming in the basement, no fine tuning. We just looked at all the history, chopped it into bite-sized chunks, and let off-shelf models read it and pull out the facts.
But the Chinese models, I was talking about this at the start of the stream as well. I was thinking of getting OpenCode Go. Because my cursor is using up. Well, I'm running out of the tokens on cursor as well, so I was thinking of switching to OpenCode Go with GLM, Minimax, and Mimo 2.5 Pro. These are pretty good models that I might try it out because it's for $5 for the first month. You get essentially $60 of inference for like the entire month. 1 month you get $60 of usage, so it's like a 1 to 6, which is not so bad as well. And like from what I searched so far, how these providers and companies work is that they get all of the inference at a package like a bundle deal so that it's cheaper, so that's why they can actually afford to do such a big subsidization like that, which is very interesting.
We store the meaning of each chunk as vectors and relationships. Who's connected to what as a graph? The brain digests the documents into facts, a memory, a dream cycle, an immune system to fight off bad information. If you've ever tried it, one prompt that's supposed to do everything is something, it stays fixed forever. One agent, one job. It's a team, not a hero. And here's the cool part. They hold meetings. Athena pulls in specialists. They actually argue, and a single answer comes out the other side. It's like having a boardroom that never sleeps, never gets tired, and somehow has no ego. So what does all this actually run? Honestly, the whole front business. Everything between a stranger exists somewhere, the inbox, drafts the email, builds the code, and then shows you before anything actually goes out. So we engineered
I'm so confused. What is this about?
for the last few. Every night, Ira runs a sleep cycle. It replays. It is empathetic.
It's literally just a bunch of like nice visualizations.
Even when the truth is ugly. And nobody ships as an empty nervous system. The agent, and from inside out, we are a 100-people factory with no data scientists. If we can grow a brain, you can too. We're not selling ours to you. We're helping you build your own. Forkmybrain.org. Go build something that remembers. Thank you.
Okay. Forkmybrain.org. I still have no idea what this is about, man. Oh, yeah. The Cactus Compute Company, right? It's like, what, 35 million parameters or something? It's so insane, man. But like, what's the use case of it though? Well, I think it doesn't work in chat, but like if we were to integrate it into like different UI, like let's say I have a to-do list, and then I create a new task there, and then it will call this model to split the task into multiple subtasks. Does that make sense? But like you need an LLM to like split the task as well. But like this is more for tool calling. So like what's the use case of I still haven't thought of like, but it's pretty cool though. It's kind of similar to function jammer as well. The function jammer is like 300 million parameters, which is way bigger, like a 10x reduction, man. It's so insane.
Chat and citations won't save you vertical AI. I'm sure many of us are building products in what innovative industry, for it be healthcare, doing this entire journey for the last 2 years. There's a key problem here, right? Chat is synchronous. If you think about it, even when you're coding, let's say you're using cloud code, be it withdrawing money or seeing how much balance you have and so on. Now, this essentially might work, long running work. What would that interface look like? Essentially designed for delegation, not participation.
Wait. Okay, let me see if the 0.04 is there yet. Yep, it's 0.4 now. Hopefully the issue has been fixed. What? It's still bugged, man. I don't know why is it still bugged. Holy shit. Oh. I don't think Composer can figure this out, man. It's literally stuck on this for like days already. I'm just gonna wait for my Claude to reset then. I don't have a choice. Yeah, or like, like calling tools then, but like what example use case would I need it? So if I were to say turn on my lights, that will be a good use case. It will call my smart home and turn on the lights. But like in the context of like a ChatGPT Codex app, where will it be used? That's what I was thinking ever since like it came out. Like, where can I apply it to the app here? Because if you look at the UI here, is so similar to Codex and ChatGPT and Claude. But like, which part of the UI will I integrate this into? I think that's one of the questions that I have. Because we're gonna use it to rename things as well. Like, does that make sense? Will it work to rename a chat? Maybe not. So I've been thinking, just where can I apply this?
Now, to keep it more concrete, I think there are 4 key pieces when building a agentic.
Okay, I think the waitlist page is broken or something, because when I try to press refresh on the page, it says couldn't refresh. And maybe it's like because it couldn't fetch the status of the user role or the waitlist status or something. That's why everyone is stuck on the waitlist page on the release build or something.
And there are 4 key features or components that you need to have so that this conveyor belt that we're imagining can work. So first thing is the easiest one. You need to find the tasks to delegate. The tasks that are coming in the conveyor belt are delegatable, right? And that can generate value for users. Second is you need ability for users to teach the agents of the supervisor should be able to come in. Similarly, in your industry, you can figure out the product in case coding, for example. And second example here is like building traces in your product. Trace how you start it back up again. In our case, we could do it very simply by pausing wherever the agent was trying to make an assumption. We pause, and then the users would come in, just like in Slack or any other chat platform. They can come and tag the agent and respond with how to deal with that particular conflict. Okay, some bonus points as well. So just as physical bank branches didn't disappear when the mobile banking arrived, or when the level 2 arrived.
Yeah, I think database queries work as well, but like it's such a small model though. Isn't it just literally just for calling tools? Like, it doesn't have the intelligence to produce a text output, isn't it? Because it's purely for calling tools. So like the smart light, turn on the lights, that one is a very good example because it doesn't need any intelligence on like natural language output. It doesn't output, if I'm not wrong. Let's say if I were to apply it to renaming chat titles, will this work then? Yeah, like I can't show it because like the app isn't working. Unless, maybe let me just run, let me see if I can run the local version. So this is a layer on top of agents. So we have all of the, I think this is a very good diagram here. So if we look at all of the agents that everyone is building, and then everyone's literally building like the same shit over and over again, we're building like the layer on top where we orchestrate all of these agents from one platform. And it comes with memory and all the context between agents for them to understand each other, what they have worked on, and so that they know whatever has been worked on and what's left to do and things like that. And then we have workflows, tools, and sub-agents all built into this orchestration layer on top of these agents that everyone else is building. And we have another layer that sits on top of this, which is the gateway that does the model routing, knowing what models can be routed to local models, and then what models can be routed to cloud models. What requests should be routed to cloud models. Essentially, all of these layers can be configured, like the firewall, the budget, what policies they want to configure. All of this will be easy. So this is not targeting at developers. This is more for normal consumers. Like, we are essentially making this very easy for normal people to do agent orchestration with all the security and everything built in, with minimal configuration. And then we can interface this entire layer here with different apps like the desktop app that I showed earlier, and the mobile app, the CLI extension, and the web app as well. And it comes with a lot of integrations in by default, all of the Hugging Face models as well. So the chat UI is literally just like ChatGPT Claude. It's intentional because I explained this in the start of the stream as well, because if you... What was the thing again? I think it's called minimum differentiation, where you try to make it as similar to your competitor products as possible, so that one of the reasons is so that the learning curve is not there. Everyone can just jump in and then start using it. There's nothing to learn to start using it. Everyone's familiar with these interfaces already. Interesting. I think it could apply to the routing layer actually. That's a good idea. Okay. Let me put it in. Actually, I could have asked. Okay. Wait. Cactus needle. Where can I apply this model, this small function calling model or function jammer in our app? Maybe I was thinking the routing, the model routing layer, or whichever, what places can we integrate this into? I think the model routing is good. That's an interesting one. I didn't think about that. So yeah, this will be exciting when it works. But like, I've been stuck in this development hell getting this shit to work. Like, there's all of these annoying bugs. I spend the entire day trying to fix it. Because every time I run out of usage as well, there's nothing I can do other than just wait for it to reset. And then I'm just stuck, man. But like, definitely it has come to a certain point. This is a very good app to use already. And I'm excited to get this out as soon as possible. By the end of the month, this app will definitely be out in some sort of beta.
I don't think went into a product as well. That's the key point here, to build trust. And second thing is, some actions are usually irreversible and are dangerous actions, and we measure this value. So the most...
Guys also changed. I'm not just using chatbots. I'm not just asking simple questions. When we got reasoning models, the
Local AI. Okay. This is wait, what? Local AI Summit.
You guys hear us? Sound check? Alright. Give it up for local AI, everyone. Woo! I hope you guys are excited as we are. This is the local AI summit. So we're gonna be here all day talking about local AI. And the reason why is we hit an inflection point this year. Not only did the models get really good, but the harnesses got really good. And this happened really fast. It's been, I think, a struggle for anyone here to keep up. I felt that most when I saw one of Andrej Karpathy's tweets. In November, he tweeted that you can't really trust these coding agents alone yet. You have to monitor them with an eye like a hawk. 3 months later, he tweets that he's struggling to keep up with the capabilities of how good this all has gone. And the thing is, both times he was right. This space is progressing really quickly, and it's wild how much you can do. And honestly, the only thing to do is just try to use it a little bit more today than you did yesterday. That's how to keep up with this space, and that's exactly what you guys are doing right here. So I'm really excited about this panel. The way that we use AI has also changed. I'm not just using chatbots. I'm not just asking simple questions. When we got reasoning models, the profile of how the AI model responded changed. Not only is it bursty and responding to me, but before the burst, it kind of plateaus for a bit. It's reasoning. It's churning on tokens that I'm not consuming. And then we got agents. And suddenly, I don't even want these agents to turn off. I want these always on agents. They can always be productive if we set them up. And so we have enterprises that want to put a lot of their IP into this because it becomes more useful. We have consumers with the same thing. I want to give it my health data, my medical records. I want to give it footage from my home camera. And both enterprises and consumers, we don't want that stuff to leak. And as you also have a profile of tokens continuously generating, suddenly costs matter. And so local is amazing for both of those things. You get to make sure that you are plateaued on the costs for the tokens that you're generating. And also, everything sits in that room. So we have amazing demos here after these talks where everything that's being run stays on those devices. It stays in this room. And so that's a really nice guarantee. So as we turn over the panels, first, do you guys want to introduce yourselves?
Yeah, should I start, please?
So
yeah, I'm Alex. I'm the co-founder and CEO of Excel Labs and also the creator of Local.ai. So we've been working on Local AI for over 2 years, which feels like a lot longer.
Local.ai? Okay. There's like nothing.
And from the days of...
Wait, why is it docked here? Yeah, this is the island app. And then, well, like the desktop app is still being built.
Of running Llama 4 FOB on 2 MacBooks to now where we have demo dev, Nematron Ultra running on 4 Sparks. Our mission is to make AI more accessible, and it's crazy to see what is possible now.
Cool. Hey everybody, I'm Matt. I make content, videos. We have a newsletter all about artificial intelligence. I'm an AI enthusiast, and yeah, thanks for having me.
Hey everyone, my name is Ahmed Osman. I am the founder and CEO of Semantic. Somebody jumped into my DMs, asked, hey, what does OS Man stand for? Open Source Man. So that became a company. And I also moderate Local AI subreddit. I have been in this local AI space since 2022. And yeah, let's make open source and local AI win. Love it. Woo. Open Source Man gets the round of applause. appropriate. Today's, I think, a pretty momentous day for the panel. Fable just came back, but it's a good reminder of why we need to have access to frontier intelligence to be able to build anything. I'm Joseph, I'm co-founder CEO at RoboFlow. We do all things vision. I kind of like to joke that vision is like the original local AI, because like everything needs to run probably concurrent with like low latency alongside your video, where the images and data is being captured. Looking forward to the discussion today and all things why local AI is the future of making AI useful for everyone. Everyone, let's give Joseph and everyone a round of applause. Woo! So one thing that I'm really excited about for all the panelists is you guys are all early to the space in your own way, and very early. And I think as we all feel this inflection point now, when do you guys feel like you felt the inflection point?
Yeah, I can go first. Sure. I mean, look, when I first saw Llama, right, I got really excited. The idea that I can actually download this intelligence running from my local computer, it was very exciting. I'm a tinker at heart. I'm a builder at heart. I've overclocked PCs for years, so this just felt like so good. So it felt so interesting to be able to have this crazy alien intelligence running on my device in my office. And that was the first time where I didn't even think it was possible, to be honest. So I saw Llama, and I was like, oh, wow, this is incredible. So that was really the point at which I was very turned on to it.
I think it's kind of the same for me. Yeah, it's Llama 2. I think that finally on my 4090 RTX 4090, I'm like, wow, I can actually understand this black box and customize it and play with parameters and like sampling parameters and all those configurations and see how inference engines work. That made me feel like something like this, like, oh, magic, I can be a wizard now with this thing. I can control how it plays to my way.
Okay, let me look at this. What needle is and isn't. Wrong layer. It says that the routing is not applicable here. If you reframe routing rules as fake tools, that's possible but awkward. It's finicky outside its training distribution. Doesn't need needle in smart routing. Okay. Tool discovery, tool search. Huh. The tool search is interesting. I guess we can apply it to tool search then. Models call describe then the real tool. Yeah, I think this might work. Today is calling tool search. What about tomorrow? Where's the tomorrow in this? Wait, I'm so confused. Ah. A third ranker. So we already have this. And then we add another layer for finding tools. I guess that's good. Okay. I guess this will work. Nice, interesting.
Ways of thinking. And from there, it was, there's this history. Basically, I've been very vocal about why local and open source AI must coexist with cloud and how we are supposed to push for that and try to understand it as much as possible and teach people about it.
Totally. I actually felt this as well. I was on a plane, I think it was in 2023, and I had a model running on my phone, and it was awful. It took 20 minutes to complete a sentence. But I didn't have internet, and so I was able to ask essentially intelligence something there in the plane, and that was my first feeling of this is going to be something really cool.
Do you know that you can run the equivalent of GPT-4o on your iPhone now?
Really?
Yeah, it's Qwen 3.5, the 4 billion parameters. It's basically the same quality as something that used to be served in data centers, and it's in a device in your pocket.
Yeah, that's crazy.
Yeah, if you just think about
Wow. I didn't know 4.0 is like the same
stuff was just,
as Qwen.
where things were going because it was a toy, right? It was like, the first, I think there were a few key points for me. One was like running Llama 4.5b locally, right? That was like the first really big open source model. And I remember like the gap, it closed the gap quite significantly with the frontier closed models and open, but it ran at 2 tokens a second. So it wasn't useful, right? And then, another big moment was DeepSeek, both V3 and R1. DeepSeek V3 was like a massive MOE. So like, Llama 4.5b was dense, so super slow. MOE seemed to unlock the performance. So it's like, oh wow, with the devices I already have, like with a Mac Studio or Spark, I can run this massive model at actually like decent performance, which is comparable with what you can run in the cloud. And then I think just recently, to me, GLM 5.2 is a big moment as well, because again, it's closing the gap and it's like Opus level, and we had it running over there on a device that like literally can fit on your desk, the DGX station. So this is to me just like a trend, and it's going to keep increasing, right? Like there's going to be smaller and smaller devices with less memory, better compression. We'll be able to run more capable models locally, and soon it'll be the default.
I'll keep with the theme of airplane stories. So, I agree that there's been like multiple moments over time of what's been going on, but I have a presentation for that after this, so stay around, please. All right. One example moment where this came up for me was I was on a plane. I was sitting next to someone. Man, this is maybe 2-3 years ago, and they were hard to cite. And they were using, if you on Apple, if you take a photo of something, you can use the accessibility settings, and it'll describe the photo to you. And we were sitting on the plane together, and they were taking constant photos to understand where we were seated and how to get buckled in and these sorts of things. And I remember they took a photo of the seat back in front of them, and the Apple accessibility described the photo, described it as like a printer or something. It was like, oh yeah, like you're seated like by a printer. And of course, the individual knew from the context that couldn't be right. And I was like, I wonder, Lava had just come out, a multimodal model that like kind of just described things with like the pivot to text space rather than like natively multimodal, but still kind of a useful example. And I was curious, I was like, well, let's see how Lava would do on the same thing. So I took a photo of like the seat tray in front of me, and it aptly described it. It's like, hey, you're on an airplane, that's a seat tray. And I showed the person sitting next to me who had never seen local models and never experienced local AI. And what that stood out to me was like, man, a company that's $1 trillion plus market cap business shipping the latest intelligence on their phones for describing visual settings is inferior to something that's broadly accessible and available to anyone. And that was such like a watershed clear moment that like even the largest companies don't have a monopoly on the frontier of intelligence. And so increasingly making that be accessible to others is, I think, going to be critical for us understanding all the massive impacts the tech will have.
And that was lava. Yeah, it's interesting to hear.
That's like 2022, 2023.
Around there. Yeah, that was a while ago. It's interesting to hear you say about the accessibility of that, right? Taking this frontier intelligence, what made it useful was giving it peripherals, in this case, cameras, so they could access the data in front of you. And I think that's where the inflection point this year was so much more than just models, but also these harnesses and what you can give it access to. It was CLIs, so that you can give business systems and plug those right into your agent. It was, 4.0 was really exciting because I was coding with it, right? I was taking code snippets from my code base, and then I'd go to ChatGPT and I'd paste it. I'd give it as much context as I thought I should, and then I would take the result and I'd go back into my code base and paste it. And what was really great about tools like Cursor was it essentially was this harness that said, what if I just had the full file system, and I can let these agents reason on what files they needed and so on. And so the way that you get more use out of all of this local, out of all these local models and systems is how can it interact with the real world? I'm curious, Joseph. So you guys got to start in Vision, and it seems like Vision had to learn the hard way what a lot of LLMs are discovering right now. What do you think is like a big lesson that the language world is discovering right now that we could look to Vision for?
I think one of the things that language has an advantage of is inherently a human construct. So language generally exists where people exist, and it also means usually you can use infinite amounts of compute, or what is available in a data center. Whereas a lot of Vision, you're compute constrained. You're running maybe where there's low internet connectivity, you're running on a device, you're running on a robot, and the amount of compute you have available to you is what you get. And so what did that do? That created, I think, an emphasis on specialized learners faster, because it's like, okay, I need this model to run in a limited context, and I'm not going to prioritize full world-scale generalizability. Instead, I'm going to have specialized in-domain context work. And what's interesting is I think you're actually seeing language follow a similar thing. You're describing the context of like harnesses for a given context, but tools like any sort of coding agents where you have a really good harness and is specialized for doing those sorts of tasks. But you're also seeing that even in like tax preparation or legal preparation of last mile fine-tuning, adaptation, specialized learners. And so in some ways, I feel like the pendulum's swinging back to actually having specialized models, even in language, just as much as Vision. I think is one thing. And then there's a whole different thing around how you get the most out of compute optimization running on an edge device. But I know that probably Exo folks can talk.
Absolutely.
But yeah, I think specialized models. You remember there's like one model will rule them all world was what I kind of thought. I feel like the pendulum swung back to people who realize specialized
models. I think we definitely at NVIDIA we see that it's going to be a multi-model world. Yeah. We definitely agree with that. There's actually one of the panels that's coming on later. I think at 3:20 p.m. is all about model routing. So I guess as an enthusiast and as you use some of this, is that how your use pattern looks? Are you using many models? What does that kind of look like? Yeah, absolutely. Everything from obviously like the top models, Fable, to kind of the more workhorse models with Sonnet, local models for things that maybe don't depend as much on low latency. Yeah, like the multi-model world seems like a no-brainer at this point, especially as you're seeing all these enterprise companies come out and look at their budgets and think, okay, well, I need to continue to increase the total number of tokens that I'm consuming as a company, but I also don't want to just completely blow out my budget. I know Coinbase and Brian Armstrong just came out with that just great post the other day talking about how their tokens are exploding, yet their costs are staying flat. And that is because they're using a mixture of different models. You don't need the top model for every single use case. And in fact, most use cases you don't. I think the most obvious application is let the top model plan, the architecture, whatever the kind of top level plan is, and then the actual execution of the code can go to a more reasonably priced, smaller model.
Your most intelligent should provide you with the overall plan and then subtasks for your smaller executioner models, and that's exactly the future.
Yeah, especially like we're talking about local. The local models are great at writing code, but maybe we offload the actual top level planning to one of the frontier models, and you save a bunch, you control more of the workflow. It's a nice pattern. Yeah, I think the market wants this. So it wasn't clear like a few years ago when this stuff was just starting to play out, would there just be one big model that everyone is using? But clearly that is not what people want. That is not what enterprises want. They don't want to be told what they can do by Dario. They don't want to be paying for the same model for all their workloads when some workloads don't actually need a gigantic model that costs $50 per million tokens. They want control, they want sovereignty, they want the ability to switch out models. They don't want to get rug pulled, from one day to the other because of some safety risk or whatever. And that's really what's driving a lot of this progress. So I'm more optimistic than ever, I think, about sort of where things are going with local. I think that the market is basically pulling a lot of this stuff out of startups, out of enterprises that are building solutions around this, and it's happening, right? Really, I feel like this is a new frontier where as we go multi-model, that becomes really difficult. Of course, you need to route between the models, but then you have to figure out how to provide necessary context to whichever model you're routing to. If you were making a plan and then breaking it off into sub-agents, what is the framework to do so? How should you do this? These are all open problems, and I think just being playful is kind of the best way to approach this. But I like the way that you worded that. Like the market's kind of pulling for these answers. It's reaching in this direction. We're looking for startups and companies to fill this gap. Makes a ton of sense. You know what's funny? As any enterprise consumes any piece of software, it matters a lot. If you're going to build a foundation, you want to know what the versions are, you want to know what your model is, whether that version changed in order to see change behavior later. So having also more control over all of this, so that you know exactly what version it is, it can't be changed, not even because of any sort of regulation, but just simply if there are updates, you choose when you're opting into whatever it is on your entire stack.
Yeah. No. So when you think about this wave that we're seeing here of like this civilizational infrastructure that is called AI, you have to consider the potential of things being taken away from you and your sovereignty, and how can you be in charge of this thing full stack end to end. That's hardware, software, and everything in between. That's the model weights. That's the specific version of the model, as you were saying. That's how you fine tune it. And picking up on Joseph's statement here about small and specialized models, I have been a proponent of that for quite some time. Like I have tweets about that in 2024 saying small and specialized models are the future, and it is going to be their use case, their workflow for businesses, to decide on their niche domains, and you need to start onboarding them now because you want to collect the data points, the traces. That's what you're asking about now. You're asking about how do we get there? How do we decide which model gets routed to? How do we decide which use case goes to which model or which endpoint? You need to collect data, and you need to be ready to basically break down the traces that you collected from your employees, from everybody in your organization, and decide how can we make the most optimal use case of these data points to which models, and collect feedback as well. And you can actually automate that with agents as well. So like this is like something that it's the whole thing about RSI right now, recursive self-improvement. It also applies to even agents and harnesses and to workflows and to use cases and to enterprises.
You want to describe that for everyone too? Maybe for folks who don't know RSI.
Recursive self-improvement. It means that a model would basically rent its own compute and then start training its own checkpoints and then deploy its next version so that it gets updated in certain ways, change its behavior in certain ways. So basically, a model is training itself.
Totally. For our product Brev, which just makes it really easy to get a GPU, we've been focusing more on agents as a first-class audience because we're seeing this. So we're seeing growing usage from agents that just want
want to go grab a GPU directly. Exactly. So yeah, you know what's funny? So the second thing you talked about was not just multi-model, but then all these optimizations to actually run it performant when you have less compute than in a, say, data center. I think, Alex, this is some fun work that we did. So Alex has actually set up a second headquarters inside of NVIDIA. We got a conference room, and we were having dinner, and he mentioned that he really was motivated to squeeze out every drop of performance we could on the DGX Spark. And so we said, hey, let's get a conference room at NVIDIA. Come bring your team, and anytime you need an expert across any pillar, let's just go and pull that person into the room. And yeah.
I actually have a follow-up here. So since I have been part of local Llama for quite some time, when I think about home libraries, I think about the individuals that are actually are within enterprises on boardrooms making decisions about the models that we're going to host or where we're going to get our AI from. The things that these home libraries focus on are optimizations. It's basically how can I extract most economical value out of the hardware, the constraints that I have, the software that I have. Quantizations came to be because of that. When we're thinking about enterprises, it's the same thing. It's constraints, it's budget limitations. It's how can I make the most use of the number of tokens that I can get under the hardware that I have. Whether that's a DGX station, centrally in a small middle-sized business, or a DGX P300 cluster. Yeah. It's all about how can I optimize the software for the latest and greatest frontier open source model out there and get as much value as possible out of it under the economical constraints that we have. 100%. I think it's crucial to see home libraries, and that's why this is local AI. It's local AI, but it could be on premises, it could be co-located hardware, it could be rented clusters, it could be from Brev. Yeah. Basically, it's just the idea about controlling this thing end to end, from hardware to software to model endpoints to model weights, and
yeah.
to train your specialized and smaller models. That's
Actually, that's the whole point of Ryu as well, where we actually have first-class support for local models. It's all built in, and that's why it's very important to build this piece as well. So local models are integrated into Ryu by default, and that's exciting, man.
Yeah, the future is great and the future is local.
Yeah, absolutely. Making sure it's your dates, your weights, your compute. I think one thing that was really interesting, we did end up getting 10x performance improvements on the DGX Spark, and we sent an update to Jensen, to the executive staff, to the teams that were helping. And one line I really liked in that email was that we didn't solve any new computer science to do this. We actually took things that the experts at NVIDIA had already solved and was out there. And I think what we worked together to do really nicely was assemble it in a bouquet. And I think that speaks to some of the usability here, right? We're talking about what is capable, what are the capabilities, but do you feel like it's just capabilities that are holding people back from adopting this?
Yeah. So just to tell the story a little bit what happened here. So I think we had dinner on Thursday of the week, and then an email got sent out on Friday. So this idea came up, like, why don't we do a lab, right? Why don't we this to me sounded crazy at the time. I didn't think this would be possible, but it was like, Nat was like, oh, let's get a bunch of people from NVIDIA to help you guys and work with you guys to improve the performance on the Spark, right? And I was like, okay, let's, if we can, that'd be great. Email got sent out, I think, pretty much that night. And then on Friday, Nat told me, be here on Monday at NVIDIA HQ. We're going to have teams of people here that are going to work together with you on this. And turn up on Monday, and Jensen talks about this concept of swarming. It's basically the idea that the whole company will mobilize around something.
Have you ever seen little kids play soccer? There's a ball and everyone just attacks it. It's like a tackle. It's just the motion of the soccer ball.
Yeah, I'd heard about this idea, but I'd never experienced it. And I can tell you, we were just back to back that whole day. People coming in and out of the room, from all various teams, like the Nematron team, people working on data center stuff, people working on VLLM. I realized NVIDIA has a team for everything. So there's like a VLLM for Spark team, which is oddly specific, but they have all these teams, and we basically got to pull those resources in. And in those 3 weeks or so, as you mentioned, we basically got 10x performance versus what NVIDIA had running on the Spark in their existing playbook, which was using Hermes Agent. So we did a bunch of optimizations there using VLM. As the sort of inference backend there, doing a lot of work with tuning the models, quantizing the models to be fit for local. So what you'll find is, I think one of the great things NVIDIA has done with the local hardware is it's the same architecture that's running in the data center as running on the Spark. So it's Grace Blackwell. So the hardware is fundamentally the same, meaning you actually get a lot of things for free. So for example, the kernels are already really good. However, there is a lot of tuning and a lot of configuration that is right now designed specifically for the data center. So a lot of the work that we did was not inventing anything new, but it was literally just tweaking things to work more performantly on the Spark. And the hardware is extremely capable. It's it is data center level hardware that's literally can sit on your desk. So it's just about how do we activate that? And I think this has been one of my learnings from the last few years is we already have the hardware. The hardware is already really good, and the models are getting better. They're getting a lot better at compression, so you can fit more on a smaller device. So I think it really is just a matter of more people looking at the space and working in it, and we will be able to do amazing things. We have Nematron 3 Ultra. It's a 550 billion parameter model running on 4 Sparks over there, 30 tokens per second. So that's huge.
I want to say something here. It's so great to see the community being proactive. I think of Alex Streamer right here as somebody who's a member of the community who's trying to push the frontier of open source intelligence to the next level. I love how NVIDIA is working with them on that. When I think about this space, I think we're in the 90s of the Linux operating system, and we are just starting. The infrastructure is not there yet. We need so much more. I was even telling Alex I want to see how we can collaborate. We have an open source deployment system called ODS that is a bunch of open source tools that we deploy in each hardware to configure stuff, configures agents, and basically gets you set gets you set up with the entire infrastructure end to end that you need for your agents locally. This kind of stuff, we need that optimized for your agents.
Wait,
hardware called ODS.
ODS?
So much more. And we are just starting. The infrastructure is not there yet. We need so much more. I was even telling Alex I want to see how we can collaborate. We have an open source deployment system called ODS that is a bunch of open source tools that
Oh. Okay. Interesting. It's kind of similar to what we're doing here at Ryu as well. We're orchestrating the entire infrastructure here. That's the missing layer here today. And more people are realizing that as well.
we deploy in each hardware to configure stuff, configures agents, and basically gets you set gets you set up with the entire infrastructure end-to-end that you need for your agents locally. This kind of stuff, we need that optimized for every piece of hardware out there so that we can get more and more people onboarded, have the open source adoption, just go to the moon. That's what I want right now. This is why we're here. We want everybody to know that local open source AI can run on anything, starting from your phone to your DGX Spark, as you're saying, Alex, to DGX stations, to the next level in the data centers, and it will deliver you frontier level intelligence.
Yeah, absolutely. I think this is a really good question for you, Matt. You test everything for a mainstream audience. You're hearing about all of this technology. You're using this aggressively. Where does it still fall short for the average user for AI?
So I think about two things: the average kind of personal user, then the average enterprise using open source. I mean, it needs to basically be as simple as opening Cursor. It needs to be maybe slightly more complicated than that, or slightly more complicated than just installing codecs and opening it up. Right now, to be fair, it is quite far from that. Like the stuff these guys are doing is incredible, but it is more sophisticated than what most people, including myself, are going to be capable of. Let alone a business. I think
full-time job to just do this kind of stuff. That's why we need to automate it.
And it really does need to be point and click. And once it gets there, and there's a lot of great open source projects, there's a lot of great projects in general that are getting there, but we're still not quite there. The other thing to make it widely adopted is to allow people to better understand what use cases are appropriate for what type of model, for what type of harness, what type of hardware. Knowing exactly the use case that I can get out of my home system or something that I'm renting from a service center, that is incredibly important as well.
And I think it shouldn't be just in documentation. I think that's where open source becomes so difficult for people. I think it needs to be a point and click, and it figures it out on its own. Yes. That's what ODS is about. That's what I think EXO is about. That's what, as we grow more and more and building this infrastructure, we need to be thinking about the user experience for your average everyday user, not us as technical folks here, because this is AI.
It's amazing because whatever they're saying here is exactly what I'm solving with Ryu here. Like, literally just installing local models is literally just one click. Because we orchestrate the entire layer for local AI, and all the engines under the hood for running local AI is already installed for you and configured for you. That's the amazing part about Ryu, man.
Engineering summit, and I'm pretty sure that we all can manage our way around this stuff, but your ChatGPT users, your Claude users, whatever out there, they want this to be an alternative that is just click, play, send a message, use an agent, and done.
Yeah, most people really don't want to know about the details. They just want it to work, and even if it works seamlessly within Cursor or Codex or any of these other things, and it just worked and they didn't have to think about it, that is number one for the vast majority of people.
So interesting on that, in a multi-model world where we have to pick a model, do you think that that's something that is a product, or is that plumbing? Is that something?
No, you talked about the harness. It's exactly that. It should be whatever the kind of the front entry point to somebody's AI experience is, that should be what is choosing which model at the right time for the right use case. This is a very difficult problem. There are open source projects, closed source companies building routing. That's only one piece of it. Yeah. Right? So go ahead.
No, like Carter from NVIDIA, he's going to be a moderator here. Hey Carter, looking good, man. So I shared ODS with him, and he told me I love how it immediately downloaded that 2 billion parameter models, allowed me to start playing with it, and then it started downloading the next model that would work perfectly on my device. That's the kind of experience we need to be giving these users when we're onboarding them. Don't make them sit down and have to think about all these quantizations and all these extensions and all these weird things. That is too much work for your average user. That's how we lose them.
Yeah, it's interesting, right? Like when you're not having to deal with multi-model and you have just this generally good big model, you can kind of ask it anything. You don't have to be as sophisticated or you don't have to understand your use case too well. But as we talked about specialized models, if you're going to specialize in something, you need to know what that something is. And so the amount that, can you guys speak to maybe what it's like to move into a specialized model or to build one? Or have you
I can start with that. On the cloud, you're basically getting the normal distributions every time that they are training something. They are taking the average feedback from everybody when they are being happy or sad or they're okay with the answer, or hey, no, this is not what I meant, to go back or change the model and answer with a different model. That's the kind of feedback that allows you, cloud providers to fine-tune the next model. But if we're talking about small and specialized models for use cases, that's a lot of compute to train models. That's a lot of storage for these weights. That does not happen without each use case or each business entity, etc., focusing on their own patterns and use cases and like how they handle agents and how their employees message these agents and what workflows they're interested in. So it's really, it's per use case, it's per entity. It's not something that we can just generalize, and that's why continual learning is not being talked about by the frontier model as much. It's coming though, it will happen, and it needs to be running on local hardware for it to happen. That's how you can have something that is so optimized that is not just plotted markdown files sitting in one repo, and you think that agent is not going to lose track of which skill to update or what to edit or which memories to update, because at some point context lens becomes inefficient, and that's one issue. That's the current paradigm of agents is basically just saving to markdowns. The next one will be updating the weights, and that needs to happen locally.
Yeah, but it's funny too because there was a tweet I think by Swix. It was like, why is fine-tuning as a service not taken off? It was like a couple months ago, and I think a big reason for that is model customization itself is also a very hard problem. And then what models can you hack on? That's why NVIDIA releases Nemotron. It's an open source model, but everything from the data to the weights to the recipes for how to do so, and then of course the final model, everything is open source, just so that it is a model that you can safely use and customize.
That's interesting. I keep kind of flip-flopping on this point. I think people look at how good the generalized models are, and you give it the right context. Is that going to be better than having a fine-tuned model and all the work that comes with that? And I keep going back and forth because there is a lot of value in being able to have kind of a smaller, very specialized model, and maybe a bunch of them working in unison to accomplish whatever task you have. But I'm not sure. What do you guys think about that?
If I can chime in on this one, I think that the beauty of the open source ecosystem is that all of these paths kind of get to be explored, and then whatever wins, it's like what happens with speculative decoding. There's all these different ways of doing speculative decoding, which is this idea that you can use a smaller model to basically approximate a larger model to speed it up. And you've seen recently, literally I think in the last week, there's been 3 different quite seem to be breakthroughs in speculative decoding that have just come from different places. One from DeepSeek. There was some work that was done by Modal and the SGLang team to build D-Flash draft models for various Quen models that are a big improvement on the previous ones. There's all this work being done, and so we kind of get to see all of it, and basically whatever ends up being the best thing will just be the thing that kind of wins, right?
That's a great point where maybe it's not users and consumers actually customizing their own models and using the specialized models, but someone who has a need does so in an open source fashion so that someone else can just adopt it, right? If I'm going to start to do image gen for a particular use case, I can just go find a model. Actually, we saw this a lot also with early LoRa's on a lot of image gen models. I feel like that was really big as in the 4.0 era as well.
I think ultimately what the end user cares about is, does it solve my use case and can it do so within my budget? Yeah. And if there's another service that can manage the entire fine-tuning process, and I don't have to think, I know I keep saying I don't have to think about it. Sometimes I do think about things, but in this specific use case,
think about too many things already to add one more thing to it.
I care about my business. I don't want to think about I want it to be abstracted away from what I'm worrying about day to day.
Totally. I could describe maybe a common flow that we see that's like distillation or general model, specific model. So if you think about it, in a lot of cases, it's like if the challenge I like to pose, it's like a thought experiment, is like if you tell someone, think of any object, and it's like think of an object in your fridge. The latter of those is actually easier, and the latter of those is actually where a lot of models kind of get deployed into real world settings. So for example, you know Monterey Bay Aquarium Research Institute, MBARI, they're called. They discovered a new fish species recently, and they built a RoboFlow to process all of the underwater footage that they capture from their deep sea submarines. And they use large models like segment anything 3 and LLMs as judge to basically say, hey, let's take all this video footage and let's build a auto label pipeline to understand as many things as we can about all the video footage that we've collected. But then ultimately, Sam knows everything about things from fish to maybe architectural diagrams to items in your fridge and everything in between. But they only care about things that are, in this case, underwater deep sea exploration. And so a very common flow that we see for like the fine-tune last mile distillation is, okay, let's take the large context of an array of models, have those maybe all have a pass understanding something, use LLMs as judge to say, hey, we agree with some of that consensus, and now we have a specialized data set. Then we can use that specific model and actually run that on the submarine in real time and also post-processing for faster video.
What they are mentioning about fine-tuning as well is a good point, because I have fine-tuning as one of the modules as part of Rio as well, bringing the fine-tuning, the hard parts of fine-tuning to most people, because local models where fine-tuning is like one set together. So we have that fine-tuning feature with Unsloth as well. We extract the CLI and then make it into a UI as well. So fine-tuning will be easy for normal people as well. And I think really what they do have a good point here. The user experience is the hard part to get, because after fixing the UI for so long, I haven't got to a point where it's really like that simple to use. It's really still very hard to get to that point. To bridge a very complicated app interface to something simple is really not easy. Yeah, I don't know why even my dev one is now like that. Maybe because I have to sign out or something. Yeah. I don't know, like why is it like that now? Holy shit, man. I literally can't show it because the whole thing is so bugged.
And if you think about it, like a lot of problems are that shape, where it's like
Yeah, that's actually a good use case. So definitely it'll be good. But like, I don't know, like from what Cursor was saying, that is that it doesn't work with model routing though. But like, if you I don't know, man. Like maybe because like the model is too small to know like what. I don't know, man. Let me just ask a follow-up. So if I were to do a model routing, like is it still possible or is it not recommended? Like let's say I have like a request to do certain task, then you'll be able to use this model to determine what model to route it to. It seems like a very good use of Needle. But like, is that not possible because the model is too small to actually know the context of what model to route it to? Okay, I'll let it load.
intelligence to understand the thing, and then ultimately the problem I'm solving is specific enough, even if not fully unbounded. And a mistake I see pretty frequently is people thinking like SAM3, which is an awesome model and a great family model. It's like, okay, well, I should take SAM3 and then maybe just fine-tune SAM3. And in some ways that actually doesn't make as much sense because you lose the thing that makes SAM3 awesome, which is the open vocabulary capabilities. What might be better is like if you know you're distilling down to a specific fixed class list, then you can actually drop the large, expensive autoencoder portion of SAM and use a specific, maybe like Detter or more specialized model depending on the task that you're solving, and get all the benefits of speed up and accuracy while still having the general knowledge of preparing and curating your problem. And I think a lot of problems are of that shape.
Are you managing that pipeline for your customer?
The tooling makes it so they can do that.
You do it on their behalf? Do you give them the tooling to do it?
Give them the platform to do that, and then there's like recipes where someone can go and do that. And then like any good AI company, there's an FDE that if you want, I can sell you a around back here and they can do it for you.
That's a great example, basically, of the use cases and workflows that I was talking about when you're trying to find, like, collect the data as you go for your business, for your enterprise, and then decide how you're going to fine-tune a model, a small specialized model on those use cases as you grow. That's how you become more token efficient.
Yeah. I think this year and next year you're going to see a lot of using these like monster frontier models to bootstrap, like a more efficient setup that runs on open source. And I think that's great. Like I think this is how a lot of the open source models have been built right now, and it's proving to be like quite hard to stop that. And I would just encourage people to just move away potentially from like these frontier models, but like use them for bootstrapping that, right? So like
I love that you said that actually because that's how the word AI engineer got coined, right? When Swift released that blog post that coined it, the way that we used to build AI products was we would start with the machine learning. We would start by training a model, then we would go try to discover a use case. And what these big models allowed us to do was actually flip it. We said we could start with discovering a use case and then get into ML if it makes sense. And that was actually honestly an amazing foresight from Swift because he kind of kind of defined that pattern for us a few years ago and gave this amazing conference as well.
Yeah, it's crazy how far this conference has come in just 3 years.
Yeah, totally. I have a question. Do you guys have questions in the crowd? We have a few more minutes, and I know we were talking about opening this up if you guys want to ask the panelists directly. Just shout. Yeah.
Please go ahead.
You want to repeat the question? You just asked what are the open problems in local AI?
I can repeat it. It's what are the biggest open problems in local AI? It continues to be optimizations, and for inference, it continues to be getting things easily kickstarted, which is what ODS is, XOS for specific hardware. It continues to be how can I make the most out of my budget constraints and hardware constraints, and how can I squeeze the most performance out of that. The models that I still have the same 3090s that I used to run Llama 2 and like Dolphin fine tunes on, and now they're running Coins 3.5, Coins 3.6, 27 billion parameters with excellent performance. More on that in my next presentation. Yeah. So it comes down to the optimization, and we are still very early. That there's space for so many players, for so many contributors. We need all the help we can get to make this thing the success that it needs to be. That we need to make local AI the default. This has been my stance for years now. I've been saying open source AI.
Let's see. It is possible, but not a drop-in replacement. It can work well for simple intent-based routing if you treat models as tools and fine-tune. It's a poor fit when routing on deep context policy on infrastructure state. Yeah, definitely, man. Multi-billion MOE running as 20 smaller models than you run is faster, should be with task-specific more resources, minimizing. Yeah, essentially, is it not the same thing like those big models with like very small activation layers, like the Gemma 4 3630B or 27B with like 4 billion activation? It's the same thing, right? Needle wasn't trained to pick LLMs. It's trained on function calling datasets. I guess that's the problem here. Yeah, it wouldn't have enough context. I think that's the problem here. Yeah, if you fine tune it, I think it will work actually. Yeah. I think if you fine tune it, it will work, man.
Went for like since forever, and the way we do that is by giving the people, whether that's individuals at home, middle-sized businesses, or enterprises, an easy way to use these models in a very efficient way that doesn't give them headaches more than solve their problems.
Totally. And if you look at the panels that are happening today, those are what we believe to be the biggest open-ended questions, which is why we tried to assemble this panel. And so we have quantization, so all about talking about the footprints of the models do fit on these smaller hardware footprints. There's model routing, there's models generally. So those are kind of what we feel like are the big problems now. And as we do future local AI summits, every time the panels should change to be the topics that are kind of holding or going to usher the next chapter in. I add one thing to that. One of the biggest challenges. So I think there's two big challenges. One is what we talked about, basically the trade-off of simplicity versus customizability. It's local, it's yours, you can do different things, optimization. If it's hosted, it's built out of the box the way. That trade-off is very difficult. The second, which I actually encourage people in this room to help solve, is the importance of open models is becoming increasingly a question. And I actually think that if you think local AI is important, then you think open source AI is important. And it's actually really important to be an advocate for being able to use, change, adapt, and toy with models. And so I think that that's a problem that could increasingly be something that we feel less control over, absent advocating. That's a great point. I think everyone here feels very passionate about open source. That is why we actually have access to the space at all. That's why the space has progressed. It's a necessary competitive environment that allows for the best ideas to make their way to everybody. So definitely when there's talks about that being a threat, we need to invest and advocate for open source. And open source is so much bigger than AI, right? Like there's a reason why compute was invented on the East Coast, but Silicon Valley happened here. And it's because hippies realized that they could share ideas for free in software. I think Silicon Valley is this kind of tension between the capitalists that want to make money and hippies that want to give these ideas away for free. And that tension is what creates such an incredible environment.
Yeah. I think it's possible, but I think the problem is the context. It wouldn't have the context of one model to route it to, because it's trained on function calling. But definitely it'll be interesting to keep it in mind as well. Or maybe using function Gemma might be better because it's a bigger model.
They can coexist, by the way. You can have consumers and you can serve businesses.
And that's when the space works best.
Can I just say, if you care about this and you want to be more of an active participant, but maybe you don't want to get involved in the technical side, you're not technical, then there are ways to get involved. So there's a website that just came out called rights2intelligence.org, and this is a way for you to get involved and actually advocate for open source and to ensure that we maintain freedom of intelligence.
Awesome. So we're out of time. I want to thank you guys so much. Local AI Summit's going to be a ton of fun.
Okay.
Here's something nobody warns you about when you start building agents a lot.
You think you're building prompts. You think you're building skills or workflow. If you build long enough, especially alone, you will start building something completely different. Was rebuilding badly. And what is that? The system has 7 handoffs. Schedule first. You just reinvented CI monitoring. One skill changes its output schema, so 3 skills downstream break. You decided to add a validation at the boundary because of it. You just reinvented concept testing. An artifact looks done, but it shouldn't ship. So you add a checkpoint before it goes to the ready folder. You just reinvented staging environments. Something goes wrong, but you cannot find out which prompt, which skill, or which handoff had the bad output. So you start logging everything. You just reinvented audit trails. The reason the title says force version isn't because agents are software builds. It's because you end up needing the exact same operational guarantees. However, the agent systems give you none of it by default. Wrong voice pattern. It makes an unverified claim. It repeats an old angle. It's missing required sections, and it gets leveled ready to publish anyway. That is the agent equivalent of shipping, because the code compiled, but the test never ran. This is what I'm going to demo for you. Not the happy path, but the 3 ways the agent can lie to you, and the gate to catch it. Or block the output. Look at the output. The markdown has a caption, pinned comment, visual brief, verification log, vault assets, production. Enough time on LinkedIn, you have seen this exact same sentence thousands of times. It's generic AI marketing language. It's not my voice. It's not your voice. It's nobody's voice. But Knife Mode saved it anyway. Because the artifact has all the required sections, it has a ready status, and it.
What's a Eliza chatbot, by the way? Oh, okay. The world's first chatbot. Simple pattern matching. Huh, I see, I see. Okay, okay. Huh. So it's just basic if and else then.
Looks complete. Now watch what happens when I add one boundary. Guarded mode locks it at the voice contract. The pipeline stops before this artifact enters the publish ready folder. This is the point. The gate doesn't make the content better. If you're building a content system, this is the first gate I would recommend. If you're building any other agent system, the equivalent question
Hey, critically thinker, what's up, man?
Failure number 2 is missing verification. This piece says things with a clear semantic ownership.
What's the point of this? Let me look at this. Alright, I'll skip that.
Workshop setup. So there's some people who kind of have like never went see this presentation. This with LLMs, like your open crawl versus that it improves. So before, so what I found was like whenever I was doing research or whatever, let's see, request, keep using. You have to, right? But
Okay. I'm skipping that as well. But this one is interesting though, that the one I covered on ODS is quite similar to what we're doing. Hey Reborn, what's up, man? Yeah. It's been a while. Okay, we watched this already. So next is this. Well, not that. I'm building Ryu, man. It's I can't show it because it's bugged and I don't have any AI left because the way my stream schedule is done is on Tuesday. But like my reset is on Tuesday, so by the time it's on Tuesday, I don't have any limits left to like fix whatever. Then everything is like broken and I don't have anything to show. But we're essentially building like the layer on top of agents, like Claude, Codex, everything is underneath, and then we are like building on top. So it's pretty interesting. If you're interested, do join our Discord server as well, and I will. Can find whatever I'm building here. It's well, it's pretty standard, but you can use like different agents in one app. I think that's like the whole premise here. But like we also support local agents as well, so you can route different tasks to like different agents and as even local agents as well. That all of it is orchestrated inside here as well. And there's a bunch of integrations. Out of the box, if you look at this is the layer that we're building here. If you see OpenAI, let me just zoom in. Well, Codex, Claude Code, Pi, all of it is under here, and then our layer is being built here with like the context of different agents, whatever everyone has done, and memory tools, workflows, and all of the orchestration is being done here. And then another layer sits on top of that, which is the gateway that does the model routing, the audit, and evals, redacting all of the sensitive information. All of it is with the security built in. So that's what we're building here. And all of it can be interfaced through the desktop app, the mobile app, and the CLI, and the extension, and the hardware, which is in the future. And then the standard Telegram bots as well, and the web app. But right now, it's not working. So I suggest just starting the repo first and following me as well. And once it's done, I'll announce on the Discord for you guys to test it out. And then hopefully we'll have a first wave of testers and then we'll iron it out. Yeah, I'm actually using ACP as well. So we're going one layer on top by having security built in and local AI as well. So it's actually one step ahead of Z. And we're building not for developers, but we're building for normal people. And that's the hard part to solve as well. Because we were watching like the local AI State of the Union from AI Engineer as well. They were talking about how hard it is to set up local AI, to know like what quantization to use, what model is good, and setting the engines up to do the local inference. But Ryu actually does all of that under the hood with like the Llama CPP default installed in by default, and then we have Gemma as the default model as well. So all of it is really like simple, dead simple for anyone to use. That's the whole point of Ryu. And I'm hoping by the end of the week we have sort of like a stable, I wouldn't say stable honestly, but like I'm hoping it to be stable, at least like some sort of version that we can use, publish on the GitHub for you guys to test it out. Definitely, if you join the Discord server, I'll announce it there, or you can catch my stream as well. I will announce it on stream. But because I don't have any usage left, that's why I'm watching AI Engineer. Because my usage resets in 4 hours. So by the time then, I wouldn't be streaming anymore. Yeah. Cool, right? It's gonna be so insane if it works. But like, holy shit, man. It's so bugged. And I'm on the $200 plan as well. Which is how insane this project is. Because there's so many crazy abstraction. The abstraction layer is so mad and crazy. How many things is actually abstracting that we developers are actually used to, and then we do the abstraction for normal people. That is like the hard part that we are solving here, to abstract so many difficult parts about running local AI, doing model routing, all the security stuff, and having them coordinate and work together. These are like very difficult things to get it work, but then even developers find it hard as well. We have like frameworks like Mastra, the TypeScript AI agent SDK framework that does a lot of this as well, but it's all for developers. And then this is more for consumers. So very excited to get this out by the end of the week, man.
Engineering track today. Is everyone having fun? Yeah, I think this is going to be a great track, so get excited. All right, let's get going. My name's Jeffrey Litt. I'm a design engineer at Notion currently, and I'm here to drop a hot take for this.
Notion.
I think it is still important for people to understand how code works. Now, some of you might agree, some of you might disagree. Let's try a poll. I'm curious for this room. Raise your hand if you agree with that opinion.
Yeah, actually that's one of the planned features as well. But I would say we are trying to do an end-to-end concept here. The entire infrastructure. So if you look at our app here, what I'm envisioning is we are building like an iPhone for people to extend all of it. So we have this island app here that actually you can chat with it, and then it monitors your screen recordings and everything is local as well. In fact, all of the code is open source. And we have the desktop app as well. So what I'm trying to do by this week is to decompose the entire core architecture of the desktop app into smaller subunits, such what? Into like a Obsidian or like a WordPress plugins extensions approach, and we have an app store so they can actually enable like different things like a meetings module, whiteboard, Excalibur integration module. You can make apps like a social media scheduling app on top of Vue and inside of it, which is the cool part. So I'm trying to extract the parts into sub modules first, such that the core remains very stable and we don't have to update it. So when we have new features and everything, it will be part of a plugin instead, so that we have a stable core that people can continue using, while like the other plugins can be maintained individually. So in that sense, we become the iPhone in the sense where we have a shell for people to build on top of. So you can build your own apps on top of this as well, which is why this is so cool, because we are providing the infrastructure for you to build on top of it, like like notifications, sending to Telegram, all of it is built on top. You can build on top of it. I think that's the cool part that differentiates us from OpenClaw as well, because OpenClaw, I guess you can actually build on top of it as well, but that's mostly for developers. But like this one is really very cool because it's more for consumers. And on mobile, we're gonna do local inferencing through React Native. I think it's I forgot what was it, the React Native version of Llama's app for inferencing on mobile as well. We're gonna support that out of the box on mobile as well. And we will have the App Store support different like things as well. Like if you see the Apple App Store, it supports like iOS, Mac, Watch. So like different platforms have different support. So like our one will be some sort of like we support desktop, we support mobile, we support a Chrome extension. So you can build on top of all these surfaces essentially. And then for the web one, there will be one part of it will be part of the web app. It's if we look at the web app here, it's bugged as well, man. Well, like you can see, like the interface is exactly the same as the desktop app because this is just the shell that's being ported to the desktop, to the web app here. And then the other inference will be on the Chrome extension, where we will actually integrate Transformer.js. I'm not sure about, wait, LiteRT is, can you use LiteRT on the web as well? I think, wasn't LiteRT like deprecated or something? Like I remember I was building it like last year or something. So there will be more for the Chrome extension where you can actually inference local AI through the Chrome extension itself. That would be pretty cool, but I haven't found like a proper use case for it. But I guess we can actually add the shell for it for people to build on top of it. And I sent this on the Discord as well, like the last known UI, like how it looks like. I was using Real to build Real until like it broke. So there's context of like the plan and the sub agents as well of like whatever Claude Code is doing. And you can see like the usage limits of different ones as well. You can add teams and you can do like different routing modes like Fusion, Judge, LLM as a judge, and round robin, a round table discussion, all the different patterns into one app. Oh, it's new. Okay. I see. Oh, okay. I didn't know this, man. Holy shit. Well, this is interesting. Actually, the good thing about Real is that our engines under the hood, like Llama's app, SGLang, VLLM, and Llama, you can actually hot swap whatever engine that you want to use, and OMLX on Mac as well. So it's pretty cool. You can hot swap it. I guess we could do something similar for the Chrome extension as well, where you can swap from LiteRT to Onyx to Transformer.js. Actually, Transformer.js just uses Onyx already. Yeah, what do you use though? I am on like the $200 plan, man. It's insane. Like how fast it runs out. But definitely I tried Codex as well, but I was on the $20 plan. So that one ran out very quickly. I ran 2 prompts. One of it was like literally asking it to commit and push and fix the merge conflicts. That's all. And then another chat was something simple as well. 2 chats. I ran it out in like 15 minutes. The entire 5-hour window. I don't know what was going on with that. And that was 5.5 somewhere. It wasn't on 5.6, where everyone is complaining about 5.6 running out so fast. But like I was already running out so fast on 5.5, so I don't know what's going on, man.
Okay, maybe some selection bias. Any brave? Okay, raise your hand if you disagree with this opinion. Wow. Okay. Yeah. Maybe we'll do a debate later. Yeah. I was hoping.
But yeah, definitely. Did I paste the link in the chat already? Yeah, I did paste the link. And the Discord as well. If you're interested, I'll announce in the Discord as well when it's done.
Yeah, the AI engineer conference, so we have more. Okay, I might be preaching to the choir. I think the reality is that we are entering an era where this is a legitimate question that people are debating, right? Agents are writing tons of code for us. They're landing 50,000 line PRs, and it is getting harder to keep up. We all feel this. Now, I think the good news is there are lots of ways to understand. The days of just reading code line by line, that's not the only way anymore. And what the point of this talk is about is I want to share with you a bunch of the practices that I use to understand the code that my agents are writing for me. This includes things like explainer docs, teaching me about how my code works. My agents write quizzes for me to test my
Oh, use anti-gravity. Like, what is like the limits though? When I tested it, right? I'm on the pro plan. And then when I use it for one prompt on Opus 4.8, I used up 20% of the window. Like, what the heck? I was like, what the fuck? I asked it to like change some UI thing. And then it blew up 20% just from that. Which was when I quit, man. But I don't know how much has anti-gravity changed since then though. But like, it wasn't that long ago anyway as well. Sure, man. Happy to have more people in our Discord. And I'll post updates there as well.
Am I still really in the loop? Am I keeping up? I have agents build me micro worlds that I can inhabit to get this intuitive sense of how my code works that's deeper and richer than just a written document. And I think all of these are really exciting new possibilities that are opening up for AI to help us understand better, not worse. And so that's what the point of this talk is going to be about. And I hope I can leave you with some techniques that you can take home and use yourself.
I think once we finish the videos here, which is until design patterns, which is where? Wait, what? Yeah, there's the ACP talk as well. Okay, I'll see first.
By the way, my timer isn't running. If you could get that running, that'd be great. So I know if I'm...
Oh, it's generous now? Okay. I don't know. Maybe I'll just install it back and see how is it like.
Blabbering. Okay, but let's back up for a sec. Before we talk about how...
Like, what changed though? Like, when was this change implemented?
Let's talk about why. Why bother understanding? This is, again, it's a question now, right? And I think a lot of people get this subtly wrong. So what a lot of people think of why do humans checking? There's this mental... I actually don't hate that. If I know what's happening and get in the loop, how it works, that gives you the ability to fluidly take creative leaps. And we agree, we need to understand. To stay in the loop and understand. A lot of my coworkers do as well. System, right, here's the subsystems that are happening, how the Z layers of the painting. In an essay, there are interactive space repetition quizzes. I think of it as sort of a speed regulator. Everything AI, speed up. There's all these incentives to learn math by doing that programming. And the bugs, I was getting a feel for the machine, right? That's something that
This one is not as interesting.
Manually, but I'm just thinking about it. So I'm getting some of the benefit of doing it iteratively without the pain. I think the big takeaway here is agents can write code to help us. So here, I might ask a product manager on my team, hey, what are users asking for with this feature? And she might say, hey, I don't know, let's ask a different agent. And that agent comes in and talks to us. And what's happening here is that instead of me and my PM both talking to our own agents, we're in a shared space. We can see each other's communication. It's kind of like going from one-on-one conversations to Slack channels. You see more of the behavior happening together and you understand together. Also, having documents that you can talk about together is a really powerful component. Here, techniques. I want to bring what he envisioned is, hey, these kids, they're playing. Hey, it's still really important to understand how just taking ourselves out of loops, but actually putting ourselves more.
Okay. Yeah, it's literally like the same talk here. Literally like the same thing as the one before, man.
I named this the session local continuum, and you guys probably have argued about this in Slack. You probably talked about this in the hallway track. So let's talk about this here because code got cheap. Attention.
Yeah, like I've been on this for like the longest time, man. Oh wow. Like creating an LLM, I think that would be pretty insane though. But I think it'll be interesting to make like one simple one just for the experience, I thought of making one myself as well. And then it's I don't know, it's just that I don't see like other than the experience of creating it, I don't see any like value in creating it like from scratch, honestly. Other than just like for fun. Yeah, but pretty cool though. Like this app wouldn't have been possible if not for AI. And this would have taken me years to build because of how complex it is and how much orchestration of like different aspects and ecosystem to build the entire thing from scratch is without AI. Definitely AI has helped a lot. A lot of the great apps today wouldn't have existed if not for AI as well. Definitely it's a double-edged sword as well.
As you may know, back in December 2025, something big changed. AI engineering has changed forever, and it broke its own trend line. Actually, Swig, the organizer of AI Engineer, is collecting evidence to that single moment in time at the website called WTFhappened2025.com. I recommend you go and check it out. It's really funny. This is just one example from METR, the Machine Evaluation Center, and it shows that models, for the first time, started completing tasks that would take engineers over 16 hours to do. And in fact, we've gone way up the curve, way up the trend line after that. This is the backdrop to everything that AI engineering is experiencing.
Because we don't write code anymore. Most of us, at least. I don't see one. Can you guys give me a raise of hands if you still handcraft and write code? Most of your code? Anybody here? Most of your code is written by hand? Amazing. This is the token maxing track after all. I think the one person here who still writes code is maybe a little shy of raising their hand. That's okay. Because we don't type code anymore. We're not handcrafters. We supervise. I like to say we babysit agents. And the greatest example for this, obviously, is Boris Stern. You guys know Boris, the creator of Cloud Code at Anthropic. 100% of his code is written and authored by Cloud Code at this point. And he didn't stop being an engineer. He moved up the layer. He still ships 20 to 30 PRs, maybe more. And recently he talked about he deleted his ID. I found it really funny. Just no reason to just hand type code anymore. In fact, 80% of Anthropic's code is now AI written, and this stat is at least a few months old. It's likely more right now. And he's not the only one. Some of you have seen this chart from GitHub. Some of you have maybe remembered this chart while GitHub was down for you. The reason is GitHub is on track to get 14 billion commits this year. All of 2025, all of last year was 1 billion. They're 14xing the number of commits. They're seeing 14x the number of commits, which is insane. And most of this is AI assisted. And it's a lot of code.
Wait, what? Why is it 1.4 billion here and 14 billion here?
It's insane. And most of this is AI assisted. And it's a lot of code.
Come on, man.
And so the engineering has changed forever. And I want
Oh, wow. That's pretty cool, though. Yeah, there's post-training as well. What's eudaimonia? What's that?
I'll tell you about AI Engineering World's Fair. I've been to every single one. I'll tell you about this later. And AI Engineering is a great place to get the zeitgeist of where our career is going and how is it changing. Okay, this one obviously is 3x bigger than last year. This is just one of the rooms. There's like a bunch of rooms. 7,000 people I think we clocked in, 36 tracks. And if you want to know what happens in AI Engineering, you're gonna have to be here. So this will be a little bit of meta talk. So one of the guys at AI Engineering EU talked about code sheet. The other one talked about we should read every line of code. Let's listen to them for just a second. Okay, this is Ryan Lopopolo from OpenAI. I don't think he made it here, but this is Ryan Lopopolo from OpenAI. You guys.
High quality that solve real user problems in real code bases. Code is free. It's free to produce, free to refactor, and it is not a thing.
Oh, that's a nice, well, that's interesting. Wait, so what's the... I still don't get it.
To get hung up on anymore. Humans no longer need to concern themselves with implementation. The important thing is not the code, but the prompt and the guardrails that got you there. You can just simply say, do not produce slop. Don't accept slop, you won't get slop in your code base. But to do that requires taking short-term velocity hits in order to back up or double-click into a task to figure out what it is the agents are struggling with.
So this is Ryan Lopopolo, okay? He came up on stage at the engineer and he opened with like, hey, I'm a talking billionaire, and I want you to be as well. In fact, the talking billionaire lounge that's in front of the leadership track that you can see, that's because of him. He came up with this concept. And he got the golden card and everything. On the other side, the same conference, the other side, Mario Zechner, creator of Pi.
Slow the fuck down. Everything's broken. And then there's people that say, oh, it's been 100% built by agents. Yes, we know, it fucking sucks now. Congratulations. Agents are actually compounding boo-boos, which is my word for errors, with serial learning and no bottlenecks, and delayed pain. The delayed pain is for you. Those are my most beloved people. I don't even read the code anymore. Congratulations. Something is broken and your users are screaming, so who are you gonna call? Not yourself, because you haven't read the code. Non-critical code, sure, might slip ahead. Critical code, read every fucking line.
So two folks, same conference, day after day, talk about the one anxiety that we all feel. Should we also be reading code in 2026? By the way, these two folks are the number 6 and number 7 most watched YouTube videos from AI Engineer from all time. So they're obviously representing something that we're feeling, we're talking about. And this is being the leadership track, something that folks that report to you are talking about. Okay, should they still be reading code? And what's the level of quality? So they make the same anxiety from both ends. At this point, I probably should introduce myself. Hey, I'm Alex Volkov. I'm the host of Thursday AI Podcast. It's a podcast and newsletter. We go live every week to talk about AI. For the past 3.5 years, we've been tracking every change in the AI engineering, every release from every lab, every model. And I'm also an AI evangelist with weights and biases and core weave. What also should I tell you about myself? That I've been covering AI engineers specifically since the first one in 2023, and oh boy, has it changed. And so you can treat this as a dispatch from the front line, because all these people now are my friends, and we constantly talk about this in the speakers room in the hallway track. I couldn't stop thinking about the tension. I couldn't stop thinking about that kind of disparity between the two folks, okay? And I put them both on the line, Zechner from one end, Lopopolo on the other end. I called it a continuum, and I basically started asking people, hey, where are you on this line? Where are you a Zechner? Do you still read every line of code? Are you a Lopopolo? Do you just YOLO and don't even look at code and think agents are good enough, etc.? And let's like by both of hands, who here has committed code that they've never looked at before? Amazing, love that. Who here to go downstairs and grab the AGI pills this week's prescripted? I think Ryan had all of them. Here's one here, and you can read this yourself. 861% increase in code deletion. In fact, as you can see on the right, it was down when I took the screenshot. It was really funny. Anthropic is the company that probably uses the most AI-generated code, and their status page looks like a Christmas tree. Now, I'm not here to dunk on Anthropic. Tarek just did an incredible job back on stage, talking about Claude and etc. This may be due to scale, this may be due to other factors. I'm not here to dunk on them, but it just goes to show that they're not the recursive self-improvement where they talk about, hey, what does the future hold? They outline two scenarios. One of them says, they're still hiring humans, so nobody's removing the human, and they're both saying that human coding is still a concern. And here's my mea culpa. I promise you I'll tell you what I got wrong with framing. My mea culpa is the continuum is real. The ZL continuum is real, but it's not about the people. It's about the tasks. The continuum is real. It's not about the people. It's about the task. He's moving attention up the layer. He's saying humans are unreliable at catching repeated mistakes at the same time. Repeatedly catching mistakes at the same time. So when you do catch a mistake during the PR review, write the documentation, the linter, and the reviewer needs to remember this once, so the system will catch this type of bugs. He's not saying don't inspect your code. He's saying inspect the system, not every line. Mario, from the other end, is saying route by task. If it's not critical, let it rip. He said it. And if it's critical, you read every fucking line. How do you know what's critical? Well, his answer is easy. You read the code. My answer to add to this is also you ask your clankers. They're great at looking at a large repository and telling you, hey, this line is actually critical. You should look at this area. These primitives over here are critical. So you ask your clankers.
Ah, okay. So it's like a Twitter X GitHub? Or maybe like an X Reddit.
So they agree more than I can.
Wait, but why would you need a? Oh, so the AI model is not related to the social media, is it? It's like a separate thing, or like are you integrating it into that?
Give him credit for. And so I think at the beginning of this, the wrong question is, should I still be reading code in 2026? I think the better question right now for all of us is, what proof does this specific change need? What proof does this specific change need? And so I took Mario on the left, obviously. I took Ryan on the right, and then I took a bunch of other great AI engineers, some friends, many of them speakers at this conference. I kind of distilled their advice down to a routing table. And they told me, I think Swiss told me on Twitter, there's going to be one slide that people need to take a screenshot of. It's going to be this slide. You have to read it with me, but at the end, you're welcome to take a picture of this. This is your Monday artifact. If you don't separate, it's kind of like if I came up with an exam, and you might be sitting there and saying, hey, did you hear the news hacked?
Oh, this was before Mythos.
Right, with Fable, we check if Cloud is doing the right work. And
Nah, this is after, man.
Getting unnecessary heat on Twitter. Said this, Andre Kapati had said, it's never felt so tempting to stop looking at code at all. Move us towards the bubble. So we're going to talk about difficulty increases as well, because the review. But because they work at bigger labs, you can treat them as kind of a lighthouse that's pointing where we're all going, kind of like Gretzky escape where the puck is going to be. They're going to tell us what all of our enterprises are going to get up on. And if it's loops, then let me at least give you a TLDR, okay? Loops are basically fancy cron jobs that run on a schedule. But what they do is they discover a task and kind of start
Okay.
$1 billion product. Nobody knew the coding agents
today. And when we were thinking about this event with Alex, we kept coming back to the World's Fair. And the World's Fair actually
Nice. Okay. Just
previously sounded impossible were actually suddenly there. People could see them, they could walk into them, and they could even start to believe in them. And honestly, this event has the exact same energy.
All right, man, you're in.
It's not arriving from somewhere else. It's really being built here.
Alistair?
And much faster than most.
Alistair?
And that's why it's a little surprising that people keep saying that engineers are going away. The argument is that coding is, abstracted away, and therefore eventually we won't need engineers. Well, in fact, we think it's quite the opposite. Software ate the world, and then AI ate software.
Nice.
But now,
wait, wasn't this notification there just now?
Pushing the frontier. Yes. And you all
I guess like the
and there has never been a better time to be
the bottom one just leads to there.
Engineering has always been about solving problems for yourself and for other people as well. It's about taking the latest science and combining it with design, with taste, with judgment, and most of all, imagination to make something that people can actually use.
Wait, these are all OpenAI employees.
And the technology we're building on, then models started testing the work, and now
it did work, and by dev day of last,
there will be a lot of talk today about. The part of it here that I've got up is you dig in all the way to this. People love the CLI, they love the IDE.
And first, so you can benefit as well. One example is into an app. Every layer we actually
5.6 sol, and like I said,
and honestly, to put that in perspective, this is
PR
written in like 10 seconds. And it's not
But like the previous guy wasn't wrong though. Like they are literally like at the lighthouse, like pointing where we are supposed to go, and then they have like unlimited tokens.
I was polling, moving.
Stuff. It wakes up every 10 minutes and it coordinates his GitHub work. The agent creates threads in the sidebar, so Paul can jump in whenever the work needs additional steering. Once the manager is long-lived, tying it to a laptop just feels which work can be done that I can text, steer from Slack is the next engineering problem.
Okay. Wait. Wait, I've watched this already. The one on Theo's one.
I thought this was a lower. This is a crazy thing for me to process. The fact that what used to be a startup is now a side project. Thousands of engineers they do doing that. Yes. Like Slack accidentally did this because Slack is now the platform people run their agents and apps now, which is crazy. Slack's
Yeah, I've already watched this.
Principal engineer at Meta.
And we have a little set of slides here. We thought we'd make a little different experience today. So instead of non-interactive slides, you get some interactive slides. So if anyone's interested, you can just scan this QR code or try and make it bigger for you. And if you get fidgety, have a go and see what this does along the way. This is linked up to, by the way, so instead of slides, each NPC will reveal the slide content. So depending on how chaotic you want things to be, you have control. Everyone got that? I'm going to close that down. And over to Danielle.
Yeah, so while you guys are getting the hang of this, it seems to be working. Well, multiple people are controlling it. There's a voting system behind the scenes that will determine who wins. But if you try to, yes. It's like a little quest-giving game. But before we go any further, the reason we're doing this is that the two of us are leading some.
Yeah. Even like myself, I studied computer science. I find it hard to make models as well, like from scratch. Yeah, interesting, man.
The AI-driven gaming creation work at Meta, we've been doing that.
And you can always post it on our Discord as well, and we'll be happy to take a look.
For over a year now, and a lot of what we do on a daily basis is using AI to help generate games for the casual creator, pro creator, and everybody alike. So given that that's our full-time job, we figured that we will take you on a little bit of a journey on the games that they
this is interesting.
12 hours. So now we're gonna get started. So because it's lunch and the previous talks are a little bit delayed, so we appreciate you being here, like David was saying. But we should also be honest about why you're here, and we want to tell you what kind of value we might bring or not bring. So we're imagining if you come to this talk, you're people that are very interested in games, maybe you play a lot, or at least you're somewhat interested in how games are made. And even better, if you wanted to make them in the future, or if you made them in the past, and you're wondering how AI is going to change that. So this is the kind of talk for you. But if none of that is interesting to you, at least you can just have fun, play the game before lunch, and work up your appetite. But now we're going to get going onto the real part. In 2026, a lot of you probably have either built something like a little game, like a platformer game, or Tetris or something on Gemini. If you have not, maybe your kids, your moms, your friends have built them. Chances are it's very likely. And initially, it's very impressive because within a couple prompts, you're like, oh, here's a game. I can recognize this. And if you're lucky, it works out of the box, but not guaranteed. But the problem is that as time goes on, you would all see that the novelty kind of wears off, and a lot of what you prompt is the same. If everybody says, I want a little platformer game that looks like Mario, overall, they all kind of look similar if they work at all. So after a while, it's like, what's next? This is cool. So that's yeah, we're all moving a lot here. So if people want to see what the text actually is, it's good to just kind of not move for a while. But I don't know how many people are here. Actually, I'm not sure how many people are here, but a lot of people are controlling, so it's hard to stabilize, which is a part of the game. But the point here is that everybody can build a game over the weekend, but what is the next thing? And what does this mean really to the industry? And like in our opinion, what this means is just a lot of people previously who wanted to build games but were gated by skill sets. For example, I'm a coder, but I'm not an artist. I cannot do 3D tests, and like the real people with real and the distance is by a lot because of what they were saying all the AI tools. Now the game is about to begin, and you will see these runtime LLMs independently making decisions, achieving the goal of this game, which is to get as many cubes as possible. But as you watch, you will see some of the NPCs will make decisions to steal other NPCs.
Yeah, I watched it at 2x, man. There's so many videos, man. They have like so many. They upload like 5 a day or something. Holy shit. If I don't watch at 2x, we will never finish it, man.
These are runtime LLM-driven decisions. And updates and iterations on the games are achieved in hours, days, changer. But just like any piece of technology, the technology itself does not make the product better. We are, just like a lot of teams, still at early phases exploring how do you use runtime LLM. We imagine a lot of these kind of things like Star Trek, right? You say, imagine in front of me there's a forest, and now I'm hunting bears, and it just suddenly happens.
What's an runtime LLM?
How does it change the game building experience? Briefly.
What's a runtime LLM? Well, literally just the runtime then. Okay.
Right, so this session is called From Writing Code to Designing Systems. So, show of hands, how many...
I don't think I'll be watching this.
Creating a scale, understand the need for hardness. So,
okay.
That these things don't come out of the box with. He also discovered his fingers, but he doesn't know about his hands. So they're fascinating. They're in front of his face, but he doesn't know how he got there, and he can't bring them back. But anyway,
Design patterns for AI trust.
So we're going to see how the rest of this talk goes. But clearly, I need practice telling bedtime stories. So we're going to do one of them set out on a simple quest. They wanted to know one thing: how their business was doing. Between them and the answer lay one small, tidy pile of course, the best quests. The first was large, worried, and had a great many questions about their security posture. They defeated it.
Yeah, this is exactly what we're solving here, the AI governance part. The PII, customer data and secrets.
Questions about their security posture. They defeated it in the way that important bosses are usually defeated, not with a sword, but with paperwork. The GM could agree.
Yeah, exactly. Wait, I accidentally just
hard truth. Important bosses are usually defeated. The next monster was worse. It had many heads, and no two of them could agree on what a single word meant. To beat it, our heroes had to accept a hard truth. The systems they trusted had never actually promised to tell them the whole story. So they stopped believing any single one of them and started building something underneath all of them, a place where the data finally agreed with itself. And then came the final boss. It didn't attack. It did something even worse. It asked one question, the hardest one of all. Now, our heroes had learned a few things by then. They'd seen what happens when you send a brand new adventurer in with no guidance.
Yeah, there's so many, man. If you actually trace back, like, I don't know why they suddenly have so many. I think because they have like a lot of conferences recently. And like, if you scroll back, this is 1 month ago. We'll be scrolling for so much and it's only 1 month ago. Look at this. 2 months ago. I think the 2 months is still like the recent one. Like it's one continuous streak. 3 months. Yeah, I think it started here. This is like the first one. If you see like the 2 months gap, I think it's here, man. From here all the way what the fuck? There's so many. What the? Yeah, it's kind of like the TED talk for AI, man.
At all. And they realized the secret. You don't need a genius adventurer. You need a well-prepared one. For every adventurer, a knowledgeable guide. They can ask for directions. And then the adventurers start teaching each other so that no one ever has to start from anything and nothing again. So they gathered up everything they learned, the permissions, the definitions, the knowledgeable guide, the habit of asking for a second opinion before they believed anything. And when they had finally reached that tidy data pile, they found out that the dragon had never been the villain. And so the kingdom entered a golden age of... Just kidding. That's not the way the bedtime story ends. The actual talk starts here. Because every part of that story is a real problem. And I want to show you how 3 of them actually get solved. So our agenda for today is I'm going to talk a bit about the age of agentic GTM. And then I'm going to walk through 3 actual examples that we either have worked through as a company recently or that we've built into the credibility here for the age of agentic go-to-market, which means that we start by helping you get go-to-market data ready for AI. And that means knowing what actually happened with a data foundation and a dashboard you can use, and then helping you answer things that used to be impossible at scale with things like deep research or a multi-touch attribution model. We do a lot to help you make AI correct about your business so that it's not hallucinating and giving you trust issues. And we make sure that this data is in all the places that you want to use it. So a lot of things you used to spend money to buy are actually things that you, the person closest to the problem, can now build. So with that established, this is the age of agentic go-to-market. We have this interesting situation right now where go-to-market teams have not historically been the place where you'd find a high density of builders, at least compared to product and engineering. Never writing ideas of how they point slides. People did for mobility, it makes it accessible. And so spreadsheets and slides are no longer the can be. I want my stuff in production, generally, if you could. The thing about those second 2 groups is basically provided you with an infinite supply of valedictorian interns with computer science degrees who can help you implement all of the solutions that you probably know better than any engineer. We're going to get some interesting results. And a couple of years ago, I remember that everyone was talking about the AI hallucination problem. Somehow that big word seems to not come up as often anymore, but I think we have its older sibling now. It's a trust problem.
Yeah, exactly. Like, suddenly we don't talk about hallucinations that much anymore. But like, the fact is hallucination has always been there and is still there today.
And if you ask Claude to do something like report on revenue,
Yeah, they kinda solved it somewhat. You're not wrong though.
it doesn't say,
But like the harness like kind of but it still doesn't catch like the secrets and stuff. So like if you see like the other day I was using Claude and then it was just literally just printing my, I think it was my previous live stream as well. Like it was literally printing my API key in the chat, or like the IP address of like the machine as well. Like literally in the chat. And then it was, of course, it wasn't redacted, so it was on my stream. So it doesn't do that kind of redaction yet, but it does have like some sort of control over like whatever things that it can run, whether you want to like manually approve every single thing, or you want to let it like determine whichever it is safe to run, or we can just run it in full access mode like I usually do.
Sure, it says, here you go, and it gives you a wrong answer that looks exactly like being right. So a lot of the talks this week I think have been around the bleeding edge of technical optimizations, and a lot of the influencer fluff you see on LinkedIn and Twitter tells you about the magic improvements if you do your prompt with exactly the right incantation. I think both of those things might well be true, but I don't generally have time to do either of them. And in practice, I find that the most practical thing for working with AI is something that we all know pretty intuitively anyway, because we have a lot of experience working with other people. And in that framing, establishing trust actually isn't new either. We already know a lot about how to do this for people. So the main thesis of the talk today is actually, when in doubt, manage your agents like other humans. If you're helping a team of humans figure out how to do something, great, do that with your AI agents too. And if you take nothing else from this talk, this is my one practical tip. Use commander's intent when you prompt. This is something that comes out of the Armed Forces Doctrine, but basically tell your agents why.
Like a small model to catch all this. Yeah, like just now we were talking about this as well, like using one of the new cactus needle, which is like 27 million parameters only, but it's like a function calling model, which it's too small. And then if we were to use maybe something like a Gemma, wait, is a Gemma 270 or is that like a function calling model? Oh, it is a 270 million model. Holy shit. Because like the one I know is function Gemma. But like if you want to use this to catch, I think it might work actually. This might work. I'm not gonna lie. But like of course if you're like running on like local models already and then you have to run this as well to catch whatever it's outputting, I'm not sure how well that will work though. But like I'll consult our cursor here on that. I was asking it on the cactus needle thing as well. How about this for model routing? And actually, can we use it for either this or the cactus needle or function Gemma for catching? Well, like some of the things is like API keys you can literally just find, you can literally just catch it. That the rejects cannot catch. Okay, I'll let it think for a bit while we continue this.
And they will do it a lot better. And by the way, this works for humans.
Yeah, it might be possible actually. This might be a good point.
Well, people don't generally They like being micromanaged, so give them commands of intent and you'll get great outcomes. But beware, because the agents have been trained on material from other humans, and so they like to micromanage themselves, and that's not usually what you want. Don't tell Claude to improve itself, you'll get micromanagement. You have to pull it back and say, remember, we're talking about the why. Anyway, on to the examples. So the first one here, for our entire company, I think documentation. And then it also shows the track record of how Claude found all of this. So these book is worth reading, honestly. This ticker, the library of knowledge items about your company and the schema of prior failed queries. And so it basically gives your agent a just-in-time memory of all the important things. So we know that the fiscal year here is actually February through April, and new pipeline means things that only meet stage 2 or later. And then for everything else. And when we came back to multi-touch attribution, enabled by Opus, we actually get really interesting results that are actually pretty impressive. So we're going to look at how this workflow works, because there's this classification of challenges in go-to-market where there is no empirically correct you come up with the final version here. And if there's not enough consensus, then I'll escalate and expand the jury. But my job is not to do research on my own. It's to say, here's the final result based on a whole team of independent analysts doing a really good job of research. And this is something that we see in the real world. We would do it with humans too. Turns out multiple researchers with somebody who helps at the end is better than a single person kind of perseverating on that forever. So thus ends the 3 examples. But I have a bonus. So bonus is right here, agent tiers. In my experience, you can't fix stupid. So this basically means friends don't let friends use really bad harnesses or low intelligent models for important work. An example of this is Slackbot released its MCP client functionality a couple weeks ago. So you can now hook Slackbot up and it will talk to MCPs. And I thought, oh, that's awesome. Now everyone who has Slack can suddenly consult the upside librarian. And I was so excited to try it. And it turns out that this is horrifically stupid. So basically the general case here is any AI product where it's been crowbarred into a pre-I subscription model is probably not something
This was not a very useful video though. Okay. Let's skip that. Where are we though? Flutter. I'm not sure, but like I tried it out for my one of my school projects, and we had a hard time, man. Maybe because back then like the LLMs weren't that good, but like you could try it out. But I definitely recommend React Native more. If you want to like run local models, like there's the Llama RN one for React Native. I think the Flutter one. Oh, I can't remember what we used for Flutter. I think it was like we used Flamma. Yeah, we used this for our Flutter project. And the last update was last month, so it's not so bad yet. It's still being actively maintained. So I think either is fine. You can ask AI to build both and see which one is better for you. Okay. ACP. Let's watch the ACP one. Okay. Actually, if you need it, I can paste the link in the chat. Llama RN and Flamma.
Hi everyone, so I'm Johan from Poolside. If you haven't heard of us, so we are one of the handful of companies that are making their own foundational model from scratch, their own LLM and coding agents. Check us out if you're not aware, some cool stuff, and you should hear more soon. But what I want to talk to you about today is this. You have people seeing AI and using AI and getting vastly different experiences. If you're on Reddit, if you're on Twitter, you're going to see people that say, oh yeah, I'm never like touching code anymore, the AI is doing everything for me, it's fantastic. And others that say, what are you talking about? I'm trying it in my production app, it produces absolute garbage. What are you guys working on to do apps? Someone else is working on brownfield. The difference is that with Greenfield, the agent's intuition is correct. The agent's writing the code and expect, if I write the components here, if I write the service that is not aware of in different parts of the code that it hasn't even exactly what the agent means between those two types of users. Like the first category is going to see some things. Oh yeah, actually, you know what? It's not working agent. Can you try stuff you've already seen in things like GStack, for instance, being able to take screenshots of the applications, being able to take a snapshot, that is to say like a very token compressed version of what's going on a web page and use it. But our application is not a web page. It's an extension within VS Code. So already like it takes an extra step to get there. But with that, our AI can interface with it just like it would with a normal web.
Yeah. That will be part of the app as well, inside Reel. And definitely Fusion is one part of it. We can use yeah, man, it'll be cool, but like it won't be like out of the box. Like there's like preset models or something. Maybe you can have like some templates, but like you have to configure like the presets yourself, like whatever model you want. Maybe you can have like some defaults, but definitely that will be part of the app.
But we take it further. We have things to extract logs from different services, from the backend, from the front end, ways to restart different services. High-level commands. Can you access a specific measure? Yeah, I know what's going on. You just need a margin there. You just need to go. This is not, I think, simple, but everything around that. And so, any question from anybody? Yes. The application. The way did you notice any issues? Any like a?
I don't understand what was that talk about.
And so that's why we decided we need some type of protocol called
ACP. This is the one that we're using.
LSP, it's a JSON RPC based protocol, and the idea is basically that agents and clients can talk to each other through a unified interface.
Okay. Cursor is back. Let's see. Huh. Good question. 2 different jobs. For model routing, Gemma 27M is good. Or keep the existing strategies. I mean, we can add like this as one of the methods for you to route as well. An existing inspector. Well, that works too. Tool picking. Okay. Well, I guess it's right. Okay. We'll implement this then. Yeah, we have model routing, we have tool discovery, and the guardrails. So I guess they really clearly like laid out the what should be used for what. I think this is right. Yeah. Okay, I'll edit when my usage resets. After I decompose into the smaller modules as well. That's gonna be a very big refactor. But that will be a very nice long-term gain in terms of maintainability. Yeah, but for sure, the small models will be very good with that. I'm excited as well for this to be out, man.
You can contribute if you want. At this point, we have a wide variety of agents already supporting this, either by like an adapter that kind of like translates the agent's native language to the ACP one, and then we have like, for example, OpenCode and Cursor having like ACP mode built into their like CLI agents. And we also have a bunch of clients at this point, up to 40 that implement this, including OpenClaw, for example. Like OpenClaw itself is a client and a server, actually, like a client and an agent. And JetBrains and Obsidian and other people are supporting this. Great. So I'm going to do a live coding session. Let's see how well that goes. Right. Basically, we have some pre-existing code. So this is Z. Here I have some TypeScript code. Also, bear with me. I'm a Rust developer. I have basically zero clue about TypeScript. So if you see anything that you don't do in TypeScript, tell me afterwards. But yeah, like here's a very minimal coding agent that just doesn't support ACP, but it's kind of the very minimum you need to like build a coding agent. So all it has is really like 2 tools: one to read a file and one to edit an existing file. Yeah, this is like pretty basic. It provides the model has to provide a path, and it has to provide an old text that is like then just replaced with new text, and that's kind of everything. And then we have, in this case, like I'm using a topic. There's a way to prompt the agent. The user can prompt the agent, which is the function that we were going to call here, and then we enter the agent loop, and this is kind of like the way all agents basically work. Is the model APIs are stateless, so you just attach some like conversation up to this point. You call the endpoint, in this case it's like the Anthropic API, and then we get like a message from the model, and either it can be like an end turn, that means like the model decided to just output some text and do nothing, or it can call a tool. And in this case, it would be like a read or a write tool call. And then in the case of a tool call, we like run the, for example, the edit file tool call locally, collect the result, and then send it up to the model again. That's why there's this loop. And then we call the API again with the conversation up to that point, and that's kind of everything. And then we have like this like handle tool call function here, which handles like read and write tool calls, which does what you expect. We get the path, we read it from the file system, and we return some result. Right. So now the question is, how do we make this thing ACP compatible?
Oh, okay. What's the smallest model? 800 million. Ah, okay. I think we'll go with Gemma, man. But I think we can allow the user to choose as well, whatever they want to run to do that.
And hopefully we can do it in 10 minutes. So let's see. So yeah, I have some boilerplate here. In this case, I'm using the TypeScript SDK, as I said. And the way this works, you implement the agent interface provided by this library. And then you have to, at minimum, implement these 4 functions. So the first one that we're looking at is kind of this initialize here. All we really have to do here is like respond with the protocol version we support, which in this case is just the latest. There's also like some capabilities, like client and the agent can itself advertise capabilities of stuff it supports, but we're building a very minimal coding agent, so we don't support anything outside that's necessary, I guess. And then for us, like authentication.
So he's trying to build an agent on ACP.
Earlier, which then to the client.
Okay.
Not actually on the file system. Sorry. Am I out of time, or do I still have? And that's it basically. Thank you. Yeah, so that's
nice. That's interesting.
In 15 minutes or so.
Okay.
Cool. Hi everyone, my name is Nunu, and I want to talk to you about how we spent the last 4 months teaching coding agents to master spreadsheets. Essentially, our goal was to get coding agents to be as good at spreadsheets as they are at Python, JavaScript, or whatever your favorite language is.
REPL.
At around 50% accuracy on a there's a revenue table here, assumptions in the formula, and it's didn't. Then because discovery with different agents, so it just turned out to be one didn't of the larger solution. And that's kind of the advantage of this architecture. You just use the scripting language for what it's good at, which is letting the agents interact with it, and use the right language to then deal with the actual files. And what it looked like before and after. And another nice and then iterate.
Okay.
Code. And you give it a feature, and you're like, okay, cool. Can you build this for me? And Cloud Code starts putting it out into subtasks, and you see it. Okay,
Checkout.com.
All right, that's really cool. And you see like ripping through all of your tasks, sub-agents being completed, and it gives you like a final output, task completed. Like amazing, great. But when you try to run it, it should be like, oh well, something has failed. Hey, Claude, can you fix this little bit thing? Oh well, let's try it again. Okay, it's fixed. Everything should be working. Oh no, actually, this tiny little thing is just missing. So, and that's what my talk is about. All I want to do is play Cyberpunk on my Xbox while have Cloud Code do some work for me. And what I realized was the problem is that I kept on telling Cloud like, hey, fix this, fix that, fix this, fix that. Even though if I give it a spec, if I give it some instructions, if I give it little to no instructions, every time there is something that I need to tell it. So what that means is like I am the enforcement. I am the enforcement there. I have or not. Actually, the way I wanted it to be done, because it says it is done, but is it the way that I want it? So I needed some way, deterministic way to do that. I'm just talking in general about LLM agents in general. Is when I give a task to a coding agent, does it actually complete it? Smart, you won't need enforcement. Okay. So crisis mode. Did I just waste my time? Servers that can have the best sub agents that can get all the right context. So it has to be a pattern that is LLM and LLM as a judge sort of a thing. And it can run on any different language, on any different code. As long as there's a capability to run it deterministically, we can have that. So what I realized was we're doing this as well. So Anthropic has recently released their new thing called Executed Advisor pattern, where you've got one agent that actually does all the code work, and then there's an advisor that feeds in, essentially creates a feedback loop. Or in other words,
Yeah, this is what I'm using here. I use Fable as the advisor, but like it's like broken, man. But like right now I'm using Opus to execute and then Opus to advise as well. But like when I use Sonnet to execute, like the code it wrote was pretty bad. So I decided to just switch to Opus for everything, man.
build their own harness engineering, and it's the same idea. Like you give an agent a lot of things to do, but how do you verify it to work? You give it different tools, you give it different context, and that's essentially what a harness is for OpenAI. There are companies like Kudo who are over here that provide a very comprehensive code reviews. And again, it's the same thing. The agent has done all of its work, but do you trust it? No. So what do? You do a very comprehensive PR review with all the different issues and findings, and create this feedback loop. Something from today as well from WorkOS. So it says enforce, don't instruct. So it is all about like running these checks deterministically. When I say checks, it's just about the verification. Another one, which is my favorite, is one of the favorites. Like you still have to go slow. And so TLDR, it's called vector harness. But if you send me a message on LinkedIn, I can.
Okay. A chess YouTube channel.
Forked, because this knight magically controls both g4 and h5. The king must step aside to f8, and the knight captures the queen on h5. This is a gorgeous double-duty fork.
Built an agent which has
Oh wow. Okay.
to sacrifice on the most human moves. Also in the historical context, there might be like some valuable information.
Hello, I'm Kyle. I run a fleet of AI coding agents across 3 machines every day, and this is the always on. Linux A takes the long-running coding tasks. Linux is the mess that broke me. I just couldn't hold what 6 agents were doing at once. My own attention was the bottleneck. So I asked myself kind of a strange question. How does a handful
This
of
is AI written script.
in their heads? They separate context. Each person only ever sees their own slice, and that was the unlock. What if my agents weren't a flat?
It's so clear that it's AI written, man.
CEO, VP, manager, worker. And please hear me on this. These are real entity types in the system. It is not a cute metaphor. Each one is its own agent with its own scope, context.
Like every sentence is like 5-6 words. You can already tell it's that AI that wrote the script.
And this is the single most practical thing I learned all year. When that window fills up, the built-in move is to compact, summarize the history, make room. 5 things broke. Failure. 1. My agents kept doing the work themselves instead of later, open the lid, and it had already restarted.
Hi everyone, I'm Sachin Kumar and I work as a senior data scientist at LexisNexis. This is an independent work of mine, which was all looks fine until the exact moment of behavioral testing. The model is correct on that breaks activations into sparse human readable examples. We generate them procedurally. 35 entity type model untouched sits at 53% either way. Zero swing, no trigger behavior at all. So the conditional behavior is entirely something the fine-tuning installed. Good. Now we can catch it from the inside. Tested it. This line tracks a score across 4 layers under full rank fine-tuning. The team color defense.
Picture this. It's a warm summer night. Important. We need to distribute early.
To share, to say someone decided that now was the year, and I
Running back to the artisanal. People love craft.
These talks sound very interesting.
I'm allowing the harness to emerge, stabilize, change, and someone like me who started AI engineering about 2 years ago, it's a big thing like an organization, and that organizations interact with each other. Yeah, and crucially, the system end of the scale, you've got the system reorganizes itself. That is constantly shaping and reshaping itself based on the problem space. So you need to find that in adaptive engineering, otherwise you just get drift. There is a risk of monoculture where you don't get genuine diversity amongst agents because they're all trained on the same data.
Hey, today we're going to talk about how we taught agents to use code retrieval, or how we for Broscom it's 93% in the document to find the right thing.
The agent receives up to cover separate aspects, examples in the prompt just to show that here is the point to like really improve that.
Okay.
Which is a huge jump.
Hi everyone, my name is. I realized early on that none of the existing tools or frameworks were able to do what I wanted, and I realized that what was actually needed was a language level.
What? His slide deck is in the terminal. What the fuck?
Hi everyone, my name is Audit, pronounced Audit like a text audit. And I'm here to talk to you about what if the harness mattered.
Okay, this is insane. I've never seen like a slide deck in the terminal before, bro.
I wrote blocking algorithms such as illustrated book on algorithms, and I also do illustrated posts on ducttyped.org.
And I want to talk to you about what if the harness mattered more than the model, by which I mean, what if we should be paying more attention to building expertise in harnesses?
Have you seen like a slide deck like this before?
Oh, the models are so good that you can just keep the harness simple. Just
Yeah, like okay, we have like a plugin for that, like the Go command as a plugin. And then we have a double check plugin as well, where you can specify whatever model that you want. After the response, that model will actually verify that agents work. So it's very adaptable, and you can essentially, we're building like the iPhone here. So all of it can be built on top of it. Like whatever you want to be built can be on top of it. I think that's the whole point of Real here. And to go to that vision that I have, we currently still need to decompose a lot of the core parts into sub-modules first for that to work, so that we can keep the core of Real very simple and lean. And I think we are like building the Pi agent of the desktop app version, like the infrastructure. I think we're going in that direction. Like we're building a very lean and minimal core that you can extend on top of it.
the model a few tools and it'll do the rest. And I've been hearing this so often that it has now started becoming the wisdom of the tech industry. To which my answer is yes, but that's moving in the wrong direction, because that is making us reliant on fancy proprietary models that can't be run locally. So what if we instead talked about the other direction? What if we focused on open source models that can be run locally? What if we focused on building a harness that is so good that we can get the performance of a cutting edge model through a local open source model? So what if the harness mattered more than the model? What if our focus should be on the harness? How much does the harness matter? Right, this is something I have been researching where that talks about evaluation, same model, there's language level support. Like the basics of building a harness. When we talk about building a good harness, what is that? And of course, it can't do anything. So the most obvious improvement. So let me show you what that looks like.
Man, this is so cool though.
So that you don't have to manually approve every single action, where you reason, act, observe the consequences of your action, and then decide what to do next. Modifies the code and checks that sub-agents their own code to use. In this case, we make that needs to optimize. It's going to run. So we got measured improvement and not guess and check. So, you know, I hope this gives you an idea of.
This is so cool. I might like give one of like my future talks in like this format, but it will be only applicable for like developers though. Okay. Holy shit, there's so many. Okay, we might just end the stream after I finish this
Hello, my name
the
is
ones that I
Nico,
opened
I'm
here,
software
which
engineer
is
at
a
Duolingo, and
lot.
security for the Duolingo English test. Today's talk is The Human in Your Loop Isn't Thinking. Build AI systems for discernment, not approval. So let's get started with some. Our humans were asked to look at reasoning exams, and they were given a. Lastly, we have a final. Again, to reiterate, these were not sessions that were actually going to our test takers. These were historical sessions, so there was no impact to our customers. However, this is something that was definitely very important. Earlier, we talked about the human in the loop days cleaning your data or trying to find useful insights. Instead, you're going to have structured data that is directly impacting your.
The front end for Real, I've not used Devin though, but like I'm pretty sure Devin looks similar to Codex and Claude and all those, right?
Next iteration. And this is a compounding effect, and it's cyclical. If you are.
I would say Real is very similar to Codex, and it brings the best of multiple apps as well in. So I was talking about this as well on the minimum differentiation that I saw it on one of the videos as well, where you actually try to match as much as possible with all the other competitors to make it as similar as possible, with one reason being the UX is familiar for users to just hop on board. You don't need any onboarding or hand-holding, because if the UI is so complicated, or the UI is completely new, nobody's gonna have that mental model of using a completely new app from scratch, and then they will have a learning curve to it. So that's the hard part. That's why if you just copy whatever, all the paradigms that we have now on the Codex, Cursor, Claude, all the apps look the same now. And that's the whole point, because they want you to have a mental model, because your mental model is really there, like your chat's on the left side, and then you have your chat in the middle. the mental model is already there, so there's no learning curve at all.
Not being intentional with that design, you can get stuck in a vicious cycle where your model is making confident calls and because correctly using headphones at this moment. Why is this important? For example, if there's somebody who has a hearing aid, that means that the model correctly predicted that there are headphones or earbuds detected. That is a true signal. However, we don't actually want to penalize this person for wearing hearing aids, so we don't want to flag them for a violation. Previously, as to not falsely accuse somebody of cheating, we would select no, but that would be a bad signal to give coding agents. Now, there are a lot of coding agents out there, and there's a lot of or bad, the trade-offs that it made, stylistic preferences, and approaches that the developer is taking. And all of those pieces of data can then continue to make your experience as your AI system, coding system better. So let's look at some design principles. First, you can engineer the reasoning. Think about what reasoning pattern do you want to elicit from a human, and how does your interface...
Hi everyone, my name is Andrew Dumit, and I work on AI engineering at Watershed, the sustainability area. It came to answers that vary by up to 50%. It absolutely... And beyond that, it also gave it the flexibility and power to do stuff in math where there is like a fully verifiable answer. It knows that it's looking at a sense of...
Actually, all of this is online, man.
So, to return to those three problems that we started with, now...
As for online today, you can raise your hands, but just not on your screen. How many of you have spent a significant part of your career making software move from one computer to another? CI pipelines.
Wait, what do you mean by Gen UI? Like, can the agent create UI components? Like the one that we are using here is JSON render. So, well, this one is interesting. Let's see what it generates. Yeah, so like the one that we're using is JSON render to render UI components. So it will work. But like it wasn't extensively tested yet. I would say real is still very early.
Package registries, container images, app store reviews. That entire stack. And that was a version for each person was worse. It just wasn't an option. Giving to users different software and forking the code base and hand maintain. But now, as making a change becomes as cheap as running one, and it can happen in the same place as of content versus software, what was holding up the entire building. And we do get these objections for controls and boundaries. What can and cannot be adapted to give it, and as long as they are within this signal led to this specific recommendation and this exact interesting one. And how do you make a system good enough?
Hi there, welcome to my talk. My name is Sanya, and today I'm going to share with you an experiment we did at our company that's somewhat unusual and very exciting. It was a one-month initiative called Radical Speed Month, where two-person teams were given full autonomy to build and ship projects. I built this. This is why companies are rushing to put it to use. But no matter, we couldn't all do this at once. We had to do this board game event sessions. You can see what that looked like. This is what we built in 2 hours. We built an app, maintenance, and if we would be able to necessary decisions. In large organizations, this collaboration, as well as build later.
Hi everyone, my name is multi-hour trajectories and coordinated changes across many components. These are literally hundreds of hours of human work compressed into a single agent rollout. Products intended.
SWE Marathon.
Speed Marathon has 20 project scale tasks across 4 families. There are library clones, full stack product clones, ML engineering, and algorithmic tasks. And some of these tasks even use external APIs. For example, we have a post-train task where the agent must post-train a language model using the Tinker API.
Damn, what?
Contributors from the evals community.
Grok is on top.
And then we work together to standardize them in executable environments.
Fable is here. I mean, Fable is not very good for writing. Flutter Gen UI. Okay. Wait, what do you mean though? Like generating like the components for Flutter? Oh, okay. It's like render UI for Flutter. That's cool. It's experimental though.
The average trial used 31 million tokens, and the longest rollout consumed 877 million tokens. So the agents are exploring, editing, testing, getting stuck, recovering, running for hours. With GLM 5.2 on the Next.js flight.
Stay tuned for exact timeline. Me and Kat Wu and Simon Wilson will be doing a fireside chat at 12:30. We might have some updates for you then. But Fable is a model I'm just so excited about. It's one of those Anthropic models where you're just gonna remember it. Like Sonnet 3.5 new, Opus 4, Opus 4.5. It's a model that I just have a lot of like affection and excitement for. And the best way to describe Fable to me is like the map is opening up. You know, like you were playing like an RPG and you've been on the tutorial, and now you get to the point where the open world starts, right? And there's so much that you can do and explore.
Like making another harness? I'm not sure though, but like what we don't want is to make just another harness because everyone else is just doing it. So like it's very hard to differentiate from there. So when we put one layer on top, it's way better in that sense because we aren't duplicating like the things across again and again. But like definitely based on some paper research, I think that might be a good idea as well. To anchor on some points that we might build in the future.
But it's also a little bit intimidating and confusing, right? Because there's so much you can do.
And so what I wanted to do in this talk is give you guys a field guide to Fable, right? How do you work with this new class of models? So I've got 4 parts to it. I've been working on this as a series of articles and blog posts, but when we announced Fable was coming out, I was like, okay, let me do all of this at once at the talk, speed run. So the 4 parts: unhobbling Claude, finding your unknowns, dealing with the grief, and being unreasonable. So first, unhobbling Claude. A little bit unintuitive, right? Like I saw this viral tweet a couple weeks ago, being like, why can't LLMs say which Pokemon ended AW? There are 1,000 Pokemon, right? And turns out there are 2 whose names ended AW, Croconaw and Dreadnought, right? And it turns out if you ask like a normal chat model, it can't answer it. So it's kind of confusing because it definitely knows all the names of the Pokemon, right? But if you ask Claude Code, it can, right? Because what it does is that it fetches every Pokemon and writes a script to filter for AW, right? And so this is what I mean by like unhobbling Claude. We call this capability overhang, right? That's sort of like the insight that led to Claude Code, right? And so again, spiky, like was that it would work, right? And then sometime at Opus 4.5, I was like, well, what if I asked it to ask me 40 questions about the spec? It could start interviewing me, right? And so its ability to ask questions jump knowns, because if not, it's going to traverse unknown knowns, right? Things like, especially for design, and it runs into an unknown, ask it to log in, right? So that YC startup, about 30 people, and we were just constantly forced into trade-offs because of how hard code was, right? Like we could make the app culture anthropic. And my reflection going forward is that
Yeah, of course, like an official talk has 74,000 views, right? And the rest is like 1,000 views only.
All right, so we built an agent, you launched it, everything works pretty well in the demo, fix them, and fix the problems as soon as possible, and in the future. Depending how it looks like is for the previous bottleneck in this case. And this
What was that?
So
box.sh? Right, box.sh. And the auto review skill. Oh, so it's a sandbox. Okay.
You don't need to be a bottleneck in this problem. Some of them prefer to remove the human, and the main goal is to just give me the source, find the patterns. If there are some critical ones, you have a description for each specific problems or bug. This is more on a high level that helps you to watch across hundreds or thousands of real conversations. So you can run it once in a week, 2 times in a week, or something like that. All right, so the next one is that for the problem of the previous agent.
Hi everyone, did well, and if not, what should it have done instead? That's basically the first part. It's critical because it provides expert knowledge on the behavior of the agent, and it is alignment with the way that we want agent to behave in those applications. Either way, now we have session log plus some feedback on those logs. Is it enough? The answer is no, because it is still, we can fix the issues, dig a little bit deeper into each of might have been working previously, but with these changes, even after we make
continual learning is one part that is implemented in real as well.
What do you want to change? So the first approach is okay,
but it's optional. It's sort of like Hermes agent, where you can update a skill file based on like past chats, but like it has also an extension where you can actually fine-tune a model for that as well.
Subject to having no regression of the past learning environments. And obviously this needs to be done in an efficient manner, so it doesn't scale even linearly with K, because K can grow and the complexity of this approach can
Yeah, I do agree that it won't lead to AGI, man. It's so far away from LLMs to AGI is so far away, man.
Different layers in updates to the agent, so sometimes the change can be cheap. Like for example,
I think the limitation is literally in the architecture itself. Even like you see some of the newer models, Gemma diffusion, and then I think Nvidia has a diffusion model as well. I think it's this one. So like there's more diffusion models now, but like it's, even though it's a different architecture, but like nobody's using diffusion as their main workflow though. So like clearly something is wrong here. That diffusion isn't that good, despite like the speed is being so fast and that it can actually correct itself because like it has context to the entire thing while it's actually generating it. It's a pretty good approach, but like I still think that the fundamental thing that the problem with like the intelligence is that we are not right now. We have like I think 5.6, GPT 5.6 is rumored to be 4 trillion parameters. So we have clearly scaled past 1 trillion parameters already to 4 trillion. And I think 1 trillion was pretty insane like just 1 or 2 years back. And then right now we are at 4 trillion parameters, which is pretty insane. So like scaling the parameters does increase the intelligence in somewhat, but like if you actually look at the charts itself, I really don't think there's much of a jump. Like it's like a 10-20% increase. It's really like still fundamentally, if we like scale it, let's say we have like 100 trillion parameters, it still won't get us to AGI though. What's scale independence? What does that mean?
By changing the prompt or hardness, and sometimes it can be very expensive by changing the weights of the model. Also,
Yeah, this is what we do. Like we're writing the skill, and then we have the model updates. This is 2 ways that you can use continual learning in Real.
Hello y'all, my name is Pietro, I'm the co-founder of Manifect, and today I want to talk to you about MCP apps. Then, this was like many people started talking about MCP UI because this is like such a great opportunity to ship UI with your MCP service.
Yeah, MCP apps is different from MCP UI. Actually does
which is a way to create these interactive MCP apps with these MCP servers that also return UI elements. Also, at the end of 2025, quite silently, both ChatGPT and Cloud released and opened their stores for MCP. These stores allow you to submit your MCP server and have a one-click install experience for your users.
So ChatGPT apps uses MCP apps, is it? Ah, okay. Yeah. But like the current state of what we're doing is for last year we have been going into the harness to actually make it more intelligent, and then now we're scaling past that again by having more parameters. So like AGI is really so far away, man. Huh. Okay. I think we might support MCP apps as well.
For the most time, these stores were closed instances that were designed and only allowed for design partners. But things have changed, and I'm happy to talk about this later. In January 2026, MCP UI.
Well, it's hard to say, like because we have like recursive self-improvement as well, like models training models, and then it's like just generating synthetic data. But like it's like you are literally generating data from whatever you have, and then you are like training yourself on it. Like what the fuck? Like does that even make sense? Like how does that lead to improvement? And like if we are using data that we have now, which is an abundance of data mixed with AI generated content all over the place, mixed with human data, well, we already have trained all of humanity's data already, and that's why we are going into synthetic data. But like how does that lead us to something like curing cancer, for example? That's really like so far-fetched. How does not knowing something, how to do something, get us to there when like so many years of science hasn't led us to finding the cure for cancer yet? How is AI gonna do that? I think that's the question. Because when we don't know what we don't know as humans, and LLMs are like modeled after human data after all, and a lot of the research shows that they behave like humans as well with like the manipulation. Wasn't the manipulation? Like the blackmailing stuff. And then there's a lot of other studies as well that's similar, but that I can't remember. And it's all very similar to humans. So it's like, to get to AGI is really very far away. Using just LLMs.
Say converted to MCP.
But I think LLMs is just one, like the requirement for AGI to appear is to have this LLM stage here first. So we can't skip from 0 to just AGI just like that. So I think the prerequisite for AGI is for LLMs to exist first, and then somehow in the future, we will find some new architecture that will be invented. Or we have like different things on yeah, right. We have like different modifications like speculative decoding now to use a smaller model to actually predict the bigger model to speed it up. We have all these revolutions now that is still coming up very frequently, like all this research is still being done. So, but all of it is still done on the Transformers architecture. But somehow we're gonna max out the Transformers and we're gonna milk the shit out of it, and then there's some point we cannot improve it anymore. And we're gonna find a new architecture that we can use on. And that requires the whatever we have built so far on LLMs, all of the research that we have done on LLMs, that will lead us to AGI. I think that will be the case. Like, LLMs is just a stepping stone to there. Yeah. Well, like, a lot of, like, the characters and stuff are also, like, well, I would say, like, AI girlfriend is, like, just one subset of, like, characters. You can literally talk to, like, an AI Steve Jobs. All of it is literally, like, under one parent, group. So a lot of it is still really like makeshift, but actually it does solve problems in some way for like people, but it does make it worse, like for people with like anxiety, and it makes the society even more introverted in that sense. So it's like again, like AI is a double-edged sword in like so many different areas, and in that introverted in the social sense. And then in the sense of not knowing what your code does as well, it helps you produce more, but at the same time, you don't know what the heck is going on. So there's a lot of different areas to think about.
Is now the official extension of the model context protocol that allows return UI elements within MCP servers. So this timeline is kind of an explanation of how the protocol evolved. And I think two major things happened in this timeline. First, MCP ops. MCP servers are not only returning JSON, and that allows much richer experiences. And the second thing, maybe even bigger, is that the store is open. This was a great huge move by the model providers, Anthropic, OpenAI, Cursor, basically every LLM client out there, to say, oh, MCP is a way, and we want to have a way for people to publish vetted just underneath. And this UI is a sandbox iframe, so you can, as a company developing.
Yeah, man. Feel free to ask me anything if you need help. You can ask me on the Discord as well. The Discord has a bunch of developers as well. I'm pretty sure everyone is good at something. So if you need any help, feel free to ask in the Discord. This is interesting though. It explains what MCP apps is, and I might actually implement this in. Okay, I will add support for MCP apps as well. Well, it's literally like a widget, but like the apps that we're building here is literally like a full app, man.
And rendered by the client. As you see here, this is the kind of experience that you can see on MCP app. The MCP server returns. This is an MCP syntax that makes it a bit easier. The set state primitive, and you can update what the model knows about what's being displayed. So here we have a little demo that shows this.
Oh, what emoji is that? It's like it's bundled with YouTube, is it? I've never seen that before.
The message prompts the tool, and the tool shows the UI. The state of the there is a pro shoot in this case. Clients have different behavior regarding this. You can have.
So what are they like doing here then?
There in the MCP server. Again, the primitive is very simple. This code on the left here is always from MCPUs.
They're like doing a component, is it?
So sometimes what happens is, for instance, you want your MCP server to return certain information.
Yeah.
But you want to
build and deploy MCP.
There's private information that you don't want to give to the model providers, and therefore you might want to redact that information, right? This is like a known privacy issue with MCP servers that you don't want to return and put into the.
I'm surprised like there's entire startups built on top of just a protocol. It's pretty insane, right?
You can return other outputs as well. So I wanted to show you here a few videos of.
Nice, man. Nice. I might end the stream soon. So let me just quickly
system, they're gonna scan the authentication as well. So if your server requires,
Yeah, we have a built-in marketplace as well for you to discover skills, MCP. We have a few default marketplaces, but you can add in your own as well. So that's part of it.
This is your buyer, and this is the typical AI pitch.
We're building an agentic
Oh,
AI
what the
orchestration
fuck?
for enterprise knowledge retrieval.
Wait, this is an ad or what? Holy shit, it's
Okay, so
like an
it's
ad.
agents, but not just agents. It's agents talking to other agents inside a multi-agent workflow. No, stay with me. It saves time, automates things humans don't want to do. It's autonomous intelligence for your workflows. Sound familiar? This is why so many AI products are in trouble. Founders are shipping faster than ever. Honestly, the tech is pretty epic, but you only have one shot to make your mark. And in this market, that shot lasts about the time it takes to ride an elevator. Today, I'm going to show you the 3-part fix for turning complex AI products into stories people instantly understand, remember, and want to buy. I'm Veronica Hilak. I've built products, made AI explainers that have hit 8 million views, and helped YC startups, safety orgs, and AI teams do exactly what I'm about to show you. The whole method starts with one thing: the wound. In other words, the biggest pain point. What is hurting the customer? What is the exact moment your user wants to throw their laptop out a window? Yikes. To demonstrate their wound, follow one rule. Do not start with what you built. The very first slide of your pitch should immerse people in their day-to-day of their job and show them what they are already tired of doing. So, a bad pitch: we built an agentic orchestration SecOps platform for enterprises. Yeah, that's a real pitch I've heard from a Series B startup recently. Nobody feels anything when you say that. Start with the human moment. Security teams are exhausted managing dozens of disconnected pools. Alerts live in one system, tickets in another, vulnerabilities in another, and the real investigation is buried in Slack threads and random screenshots. We fix that by putting it all into one place. That touches a wound, because I understand the emotion now. Overwhelmed, watching time bleed off the clock, making their lives harder for absolutely no reason. And if your product actually relieves that pain, now I want to hear more. The format is simple. In about 20 seconds, you need to do 3 things: identify the wound, say we fix that, then show how. Your product starts
What's
claiming
AI?
because now they can see exactly how it impacts their day-to-day. Once you've shown them the wound, your next job is to make the product click. Here's the test. Could a 17-year-old understand what you do? If not, you're probably going to lose the room. One of the fastest ways to fix that is to tie your product to a viral story people already understand. Think about the McDonald's AI drive-thru clips where it started doing ridiculous things like putting bacon on ice cream. You instantly get the problem: AI doing something stupid in public. If that is your wheelhouse, do not open with "we are an agent observability platform." Say, if McDonald's had used us, that drive-thru never would have made it to TikTok. We catch when AI agents go off script and give teams show how. Your product starts claiming space in their mind because now they can see exactly how it impacts their day-to-day. Once you've shown them the wound, your next job is to make the product click. Here's the test. Could a 17-year-old understand what you do? If not, you're probably going to lose the room. One of the fastest ways to
It's the cloud features are paid, but like, well, it's open source as well. The cloud features are paid, and the desktop app is free. But like, I'm thinking of maybe keeping some features behind a paywall, but I don't think so yet. But I think the initial phase, all of it will be free. So, but like definitely the core features like the agent collaboration and all those bringing your own subscription, that doesn't cost us anything to run. So that one will be definitely free. As long as it doesn't cost us anything to run, it's going to be free.
fix that is to tie your product to a viral story people already understand. Think about the McDonald's AI drive-thru clips where it started doing ridiculous things like putting bacon on ice cream. You instantly get the problem: AI doing something stupid in public. If that is your wheelhouse, do not open with "we are an agent observability platform." Say, if McDonald's had used us, that drive-thru never would have made it to TikTok. We catch when AI agents go off script and give teams a chance to correct them before it becomes a PR nightmare. Now it clicks because I can instantly see the value your product would bring. And if you really want to nail the product storytelling part, ban these words that no one can picture. Give me a mental image instead. Devin, the AI software engineer, great. I can picture that instantly. Or we're a smoke alarm for AI behavior, also clear. Those are not perfect technical definitions, and that is fine. At this stage, they don't have to be. They are the front doors into the rest of the conversation. You can give the technical version later to close the sale. Just don't make it the first thing people have to understand. The final step is to show the transformation. This is where you stop describing the product and start proving its value. A lot of founders will say things like, "We improve code quality with AI," or "We increase productivity." That sounds nice, but I still do not know what actually changes for me once your product enters my world. Show me what life looks like before and show me the after. Before, your support team spent 30 minutes digging through docs and tickets. With us, they ask one question and get the answer in 10 seconds with the sources attached. Now I understand the value because I can see the old world and the new one. If I cannot see what changed, I do not feel the story. So let's go back to that elevator. Yeah, we already know how that ends. Let's try again. Your team is wasting hours digging through Slack, email, and random Excel spreadsheets just to find one piece of information that you need. We fix that. We connect all that fragmented knowledge in one place so you can search it and get the answer you need in seconds. Same product, different story. 15 years ago, if you built something great, the market might have found you. That's not true anymore. The products with the clearest stories are the ones that get funded, bought, and talked about. Great tech that nobody understands dies quietly. Identify the wound, make your product click, show the transformation. Then your idea won't fail because nobody understands it. It will thrive and maybe even explode because you can explain it in an elevator. Founders, tell me what you've been running.
Yeah.
Comment.
This is very true. This is like a very good video. Like if your offer is not clear, I think this is like the hard part in it, building in the AI era as well, because every product is the same. If you can clearly pitch to everyone what your product is solving, and that's the hard part where we've been trying to figure out as well, what is like the framing and the offer that we are trying to offer here. I'm thinking, what was like the second point again?
17-year-old understand what you do? If not, you're probably going to lose the room. One of the fastest ways to fix that is to tie your product to a viral story people already understand. Think about the McDonald's AI drive-thru clips where it started doing ridiculous things like putting bacon on ice cream. You instantly get the problem, AI doing something stupid in public. If that is your wheelhouse, do not open with. We are an agent observability platform. Say, if McDonald's had used us, that drive-thru never would have made it to TikTok. We catch when AI agents go off script and give teams a chance to correct them before it becomes a PR nightmare. Now it clicks because I can instantly see the value.
Actually, this is kind of similar to the third point though. But like definitely, if we are talking about real, it's kind of like we make your agents collaborate so that they don't lose context or whatever. When I ask Claude to come out with like things like that, it cannot do it because like it doesn't have the big picture of whatever we're doing. Even if I were to send this video to them, it's not gonna know like what's the exact thing that we're kind of trying to solve. But it's been hard until we have like a first version. Then we can clearly see what is the thing that we are solving here, and then we can slowly go into that direction as well. I think right now we are really into the agent collaboration space with local AI and security built in. But it's really hard. I know like that sentence makes sense, but like to make it an offer, like whatever she has explained here, it's very difficult.
We'll start with the most familiar computer interface and make it strange again. Then I'll give you 3 key concepts. The channel, the physical transport that carries your intent. Expression, the range and richness of meaning the channel can carry. And the protocol, the shape or rules of this exchange. I'll use those 3 concepts to show you that the prompt is our present-day punch card. We'll share examples, commands with the shell, inputs, flags, then modern programming languages gave you primitives that you could compose. While powerful, step by step, each one of these is a fixed vocabulary, requiring you to express your intent by choosing from a menu the machine will accept. Natural language blew that menu open. For the first time, you can say almost anything, the way you'd say it to another person. And on the expression 1 axis, the leap is real and enormous. There's an ocean of meaning in an ordinary human request. Context, nuance, intent, all things we've never had to spell out to each other. For the first time, you can say almost anything, the way you'd say it to another person. For the first time, a machine can take it in. So here's what should bother us as engineers and designers. As it's bothered and inspired me, the channels for computers have been the same for 15 years, some 180 years. Now, with AI, we've poured an ocean of expression into it. So why does it feel like we're still sipping through a straw and struggling to learn how the AI thinks? Because there's a third idea underpinning the other 2, and it's really the one that hasn't kept up, the protocol, the rules you follow, and the shape of the interaction itself. Channels stayed the same. Expression exploded in the last 3 years with LLMs, but the protocol, prompting, is the protocol of a punch card. And the punch card's protocol is good old batch. Here's what punch card batch meant. You sat down, away from the machine, carefully encoded your entire request in advance, carried your deck to the operator, you submitted the job, and then you waited, sometimes hours, sometimes overnight. Then you read the printout, found one thing that was wrong, fixed it, resubmitted it, and waited again. The machine never engaged with you while you were thinking. That's what I mean. The prompt is still a punch card, not because of how you encode it. The encoding is powerful and awesome, because when the LLM is allowed to engage only...
Hey, thanks a lot, man. You've been in the stream for very long, man. I'll see you again. Where are you from, by the way? It's I'll end the stream soon, I think, as well. I'll see you again, man. And in the Discord as well.
And don't forget to stretch and take care.
For years, Iskandar kept learning new skills and turning them into income. Shaped his career. In revenue. But learning new skills didn't guarantee business success. By 2025, Iskos had a problem. His business was bringing in money.
Ah, okay. We have a lot of viewers from there as well. And yeah, I'll see you around, man. All the best. Enjoy work.
But every project depended on Iskos himself.
Programmer, I do not need to hire another person because I can channel my time and energy more towards...
Hello friends, I was dearly hoping to be able to come to the AI Engineering World's Fair, but family matters have intruded and I'm not able to make it. However, I will not be leaving you empty-handed. I'm going to give you the talk that I would have given in San Francisco. This talk is called The Missing Manual, How to Write Great Skills. And I think that the ability to distinguish good skills from bad skills is only because once we've got a working skill, we have a skill.md file, which is where to follow it. Skills that are no reference. In other words, it's doing 2 different things by layer. In other words, ask clarifying questions, and sediment is just write a decent, long commit message. People ask me...
Hi there, I'm Rachel Lee Neighbors, and we don't need multimodal capabilities. We're not going to be analyzing images and audio at the same time. About biology to be able to see what the raw responses were, what the expected responses were.
Yeah, see you, man, critically.
I found that in many cases, Llama's response was so close to Claude's response as to be pretty much...
I might end the stream soon. I don't know, I feel like the online videos aren't as useful. Yeah. Actually, domain-specific agents are something that we want to do in real as well. I think the best way to illustrate it is to really showcase it that we are using it. And then that will be probably next week.
If I was crazy is everybody is building agents. I have a realistic... telemetry and observability on these agents is unbelievably hard, especially at scale. Like if you want to know exactly what is getting transmitted on every single about it at scale, and the reality is there's just tons more. There's all kinds of validations and stuff.
Yeah. Like the whole reason why we're building Real is because of all of this.
And so on and so forth.
And like the harness itself, like Cloud Code already handles like a part of it like as well. So that we don't have to worry about like the navigating like the bash and all of those stuff. All of this is already handled.
On these agents is unbelievably hard, especially at scale. Like if you want to know exactly CP thing, we've heard about this, it works by giving one guy a ton of tools. That's not a realistic way to get a really large project done. So, maybe MCP is not the way, but...
So domain-specific agents, another way to see it is also specialized agents. It's kind of like the mixture of experts as well, like different experts doing different things.
We have skills, and skills are great. That is roughly the stack of information that gets passed along within the runtime of an agent. And if you take a look here, almost all of it is context. Basically everything. The system prompt tool skills for you, and some Google Sheets to go fill out some other expense reports or something like that. And then you've got skills. You're a developer, so you've got some on ChatGPT or on Claude, excuse me. And that works pretty well. Now, what if I have where the actual system prompt of the agent is written specifically to be a Figma agent? It knows everything about Figma. It knows all of its context, all of its API, all of the right places to click and the things.
Yeah, this is what I thought.
And then it has these precise tools that it needs to perform all of those actions. And
if you actually like scope it down to just this agent does this, let's say I have a post hoc agent that does all of my product analytics, and that agent is just specifically for that. And that's how it's going to be good, because it doesn't bloat the context window. It has just one function to analyze all the post hoc analytics, and then it can interface with other agents as well. Hey, thanks a lot, man. All right, man. See ya. Yeah, I stream on Thursday as well. Feel free to drop in on Thursday. I think it's Tuesday and Thursday. I don't know, man. Like sometimes things pop up and I don't stream. So the next stream might be this Thursday. So thanks for tuning in, man.
Nothing more. Just goes to go ask Gmail for any new emails about of his. That's his LLM. And here's his tools right there on the dash. 80% token efficiency for any. Just has the system message, its tools, and that before Flash do everything. Instead, it only needs to do the tasks to you. When you explain that, that's changing. All kinds of regions of the world. They don't actually need to be, I was really excited just a few days ago when Vercel released Eve. This is the first time I actually saw the term that I had been blasting out into the void come back and hit me in my own face. The framework for building agents, build a company brain, personal assistant, or domain specific is putting AI in front of customers. Blown agent. Like an agent should really have a coordinator agent that's at the very top, and then you can have a Salesforce agent, and that agent knows Salesforce inside and out. It knows all of its APIs, it has all the credentials to communicate with your Salesforce instance and all the appropriate sub-agents. And then maybe the legal team also needs like an OSHA compliance agent, which is also very complicated, and so it has a separate one for that. You kind of get the idea.
Yeah, this is good.
Hi everyone, I am Balash Rawat, and today I will talk to you about what is the last thing that AI will take. Functional consultant, I work with large ERP discussions with your stakeholders. Make the process and what before the AI boom.
Hey everyone, my name is Nishant Gupta. I'm a software engineering tech lead at Meta, working on building the training and the modern cloud infrastructure evolved around a set of assumptions with an acceptable outcome. The majority of the engineering effort moves below the model layer orchestration. This is why uncontrolled retries are one of the biggest risks in consistent views. The challenge becomes even harder when memory itself. So one of the biggest infrastructure shifts is that AI workloads increasingly resemble cluster scaling problems. Demand is positive, but raising depth is unpredictable. Workflows may run for minutes instead of milliseconds. Resource requirements vary dramatically. As a result, GPU efficiency, workload placement, elastic capacity management, and scheduling becomes critical. Inference is no longer just a small problem; it becomes a resource orchestration problem. The good news is that many of these problems are not entirely new. Distributed systems have solved something similar for decades.
Hello, agentic thing. And so I would say that most coders in the room would not argue that like the model is actually really, really useful. And so a lot of enterprises have also, anytime there's like a big model, the basic idea is that we pass like a list of nodes and a list of edges into the prompt, and we basically ask the model to perform graph questions. So we ask things like, what are all the parents of X? Or like if you started at node Y and you did like a breadth first search at depth 2, pretty common to you, right? A for loop, and basically and use those functions. Here is that like you and like 10,000 sequential calls along with the outputs, it's very likely you're going to hit like multiple compactions here, and you are basically hoping that every time it does a
Nice, man. Yeah, see ya, man. Thanks for tuning in.
You need to remember like which document, for example, basically any chat interface that you can use. So like Cloud Code, Gemini, or if capable to do. Okay, and so a lot of enterprises.
Hi everybody. Number of agents sort of frame wrong output as the feature again update certain sections or even run auto research style experiments to see that
The prompt is the platform.
There's a specification. It's not the product. The store is versioned. We create a key with value foo, then we update it to bar, then we update it to pass. So the latest value is pass at version 2. Most of the time, when we read the key, that is exactly what we get. A fresh read.
Nice, nice. Sure, man.
We simulated the parts of nuts.io. We depend.
Okay, I think I'll end the stream here. We watched quite a number of... Holy shit. But it's not a lot though. There's still so many. I'll continue on Thursday's stream. And hopefully I will try to get the things done for you as well. And that'll be it. Alright. Alright, man. I'll see you guys on Thursday. I'm surprised we got like 7 subs from this, man. Yeah, the vision is big, but like the bottleneck is the... I feel like the bottleneck is like the resource, man. I feel like we can go so far, but like without like... It's like we don't have the fuel to go there. That's like the problem here. But like to build... We want to build the initial traction first as well, so that we can at least have as many people test the app and give feedback so that we can build a really solid app. And then from there, we're gonna keep improving it as well. So yeah, thanks for tuning in. I'll see you guys on Thursday. And that'll be it.